Turn this over to Dave Hobbs. Dave is going to be really, this is one condensed class, and here you go, guys.
Good morning, guys. We'll start out a little video this morning. You hear that okay?
There's a revolution going on. Monitor.
Is it a big deal if we move that board a little bit over? I'm fine.
High tech has hit the highway and there's no turning back. But as today's vehicles become smarter and more fuel efficient, so do the challenges facing today's independent aftermarket shop. Will you be prepared for the vehicle electronics revolution? To get an idea of where we are going, we need to consider where we've been and where we are today. When fuel mileage standards and emission controls were introduced back in the early 1970s, nobody foresaw the evolution of today's complex computerized engine control systems. The early systems were only designed to regulate fuel mixture, ignition timing, and a handful of relatively simple tasks. Yet the onboard OBD2 diagnostics on the 1998 vehicle demanded more computing power than the first Apollo space capsule to the moon. When combined with the ABS and body control module, the 98's 32-bit engine control microprocessor monitored over 70 sensors and actuators at a rate of over 8,000 instructions per second, with the capability of detecting over 40 different malfunction codes. While OBD2 has brought some much-needed commonality to repairing computerized engine controls with standard connectors and standardized trouble codes, these complex systems require a higher level of skill than ever before, not to mention a whole new generation of expensive OBD2 compliant scan tools. Despite this rapidly emerging technology, the independent aftermarket shop was still able to rely on mechanical repairs for its bread and butter. Fast forward to today. Most of the automatic transmissions and transaxles in 2005 vehicles are now computer controlled, which has doubled the number of sensors and increased the malfunction codes to over 600. Communication and interaction between systems like the ABS traction control system, the power control module, and the body control module has increased dramatically. Today's microprocessors are surveying over 160 sensors at a rate of over 5 million instructions per second. In internet terms, the difference between a 1998 vehicle and a 2005 vehicle is similar to the difference between dial-up and high-speed cable. Now we are seeing mechanical systems being replaced by high-efficiency electrical systems. The 2005 vehicle may have an electric power steering system that improves fuel economy, since it is 85% more energy efficient than the conventional hydraulic system. The introduction of these systems means that today's pumps, hoses, belts, loops, and fluids will be replaced in the future by electronic controllers, sensors, and actuators. And these electronic components will become the new maintenance items. 2005 vehicles may also feature other new technologies such as cylinder deactivation, tire pressure monitoring, magnetic rheologic shock absorbers, or radar adaptive cruise control to deal with. These are just a few examples of the new technologies you will be repairing in the very near future. Beginning to see a pattern here? See where the typical independent aftermarket shop's capabilities and areas of profitability begin to shift? Well, wait until you see what's in store just down the road. All of the drive-by-wire systems such as throttle control, steering control, suspension control, and brake control are starting to surface. Consider what a typical brake job would be like in the future when motors and sensors and controllers take the place of today's hydraulic systems, which include master cylinders, wheel cylinders, boosters, lines, and fluid. Then consider the hybrid evolution. With hybrid technology, an entirely separate power bus will exist in the vehicle with banks of batteries potentially producing over 300 volts. Shorting the wrong conductors could lead to lethal consequences. The trend away from mechanical systems will continue. The familiar air conditioning compressor, water pump, and oil pump will all become electrically driven, much like the power steering pump. The internal combustion engine on the hybrid vehicle will most likely be direct injection, where fuel is injected under high pressure directly into the combustion chamber rather than the intake ports. And speaking of direct injection, the diesel power plant is enjoying extreme popularity in Europe today, thanks to its 40 to 60 plus mile per gallon fuel economy and its high torque, low vibration drivability. Common rail technology, or common rail direct injection, has eliminated the noise, smoke, and odors many Americans associate with diesel. Despite the system's complexity, independent aftermarket shops in Europe are already adapting to the new technology and profiting. By 2010, there will be over 260 sensors and actuators controlling nearly every aspect of the vehicle. That compared with 160 today and only 74 in 1998. In the 1920s, vehicles had about 30 feet of copper wire to handle all the required electrical activities. Today's vehicles have over 1.5 miles of wire, adding over 50 pounds to the vehicle. With the increase in onboard electronics, vehicles of tomorrow will be relying on a greater use of multiplexing. Multiplexing is the sharing of a common wire or circuit by multiple devices to reduce the complexity and bulk of the wiring system. Many advancements will be seen inside the passenger compartment too. For example, thermal systems will sense the temperature of the passenger and automatically adjust the temperature as needed. So, what could go wrong with the vehicle systems of 2010? The same as the vehicle systems of 2005, except that the parts needed to repair these systems will change. Now let's take a look at some of the technology you'll be seeing in the near future, and some of the parts you'll be replacing and repairing. As you can see from the chart, light vehicle powertrains in 1998 were almost entirely gasoline, while today's vehicles are a mix of gas, diesel, and hybrid powertrains. By the year 2010, the amount of hybrid and diesel powertrains sold will increase, and we're likely to see new hydrogen-based powertrains. Repair parts have already undergone a significant change since the mid-90s, and will undergo an even greater change in the next 5 years as we transition to more electrically driven components. As a result of these technological advances, the maintenance parts of today, pumps, belts, fluids, etc., will be made obsolete by the maintenance parts of the future. Sensors, actuators, ECMs, telematics, radar, cam phasers, active suspension components, electronic controllers, and sophisticated black boxes. This dramatic change will mean more opportunity for you if you're ready for the challenges that the vehicle electronics revolution will bring. That's the parts story. Now on to vehicle repair. As vehicle technology changes, so does the service environment. The well-equipped shop utilizes advanced diagnostics. Wireless handheld driver's seat diagnostic tools provide specific identification of fault codes for accurate and efficient vehicle repair. Beyond just reading specific fault codes, today's advanced diagnostic processes provide detailed information on vehicle electronic systems and integration of the vehicle-specific knowledge required to properly diagnose and repair today's high-tech vehicles. All IRL cars are a good example of changing vehicle electronics. They are all equipped with telematic systems designed and developed by Delphi. These telematic systems monitor all of the on-vehicle steps and report diagnostics back to the pit crew. In short, they give the electronic play-by-play. Telematic systems like this are being used on a number of vehicles now and will be commonplace in most vehicles in just a few short years. Using these tools, you will be ready to service and repair today's technologically advanced vehicles. You've done it before and you can do it again. How? By teaming up with industry leaders that the OEMs trust to design, develop, and manufacture today's vehicle components and systems. Delphi not only understands the direction the automotive industry is headed in, we're the ones who are creating and developing these new technologies and complex systems. As one of the industry leaders, Delphi provides technology to every vehicle manufacturer in the world. With access to original equipment parts and components, high-tech advanced diagnostic tools, and highly trained technicians, today's independent aftermarket shop can begin to provide the level of service today's consumers demand. Vehicle electronics. There's a revolution going on. A revolution creating opportunities. Take advantage as you have always done in the past.
Okay, any other instructors in the room? If you're an instructor, raise your hand, will you? All right, make a note. Another use for the candy module, a microphone stand, okay? Okay. Well, a little bit of sales hype in there. Not that I want you to go out and buy Delphi parts. Actually, I do. That's my day job, and weekends and holidays and vacation days. I do some of this training on the side because I'm a training junkie. I think a lot of you guys are too. I see some familiar faces in here. Guys that are in training classes all over. There's a guy I see at Linder's, Indianapolis, and here he is out here in New York State. So to pay back for the training, sometimes you do some, and that's why I'm here today. I'm really honored to be with ATTS and G. Trugula and some excellent instructors, John Anello and these guys, and Doc Null. This is really a great group. I'm looking around, and I know there's the creme de la creme, which I guess is French for really, 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 really good technicians. And so hope I can give you something new that'll help you in your jobs. But before I do that, I need some help from you guys. I need about, well, first I need one volunteer to come up here. One volunteer to come up to the front of the room. That's you. All right, Paul, come on up here. We're going to, after the video, I want to show you something more tangible you can stick your teeth into, like a schematic. We're going to open up this schematic of, what is it, Paul? That's the whole vehicle electrical system.
Old days.
Looks like a Model A. What years did they make the Model A? In the 20s? Late 20s? Into 30? All right, 31. Got an ignition switch, an ammeter, instrument panel lamp. Let's see, looks like two headlights, an ignition, let's see.
High tension distributor, coil.
Yeah.
Starter switch.
Starter switch.
Separate starter switch.
Windshield wiper. Wow, they had electric windshield wipers. That's interesting. Yeah, very little bit of wiring. Okay, now I need about 3 more guys to help me here. All right, there's one. You're not done yet, Paul. Okay, let's make sure we get it right side up. You're going to have to help in the middle, Mike. Just unroll her, guys. You're going to have to walk that way. Okay, got her? Okay. That's a 1998 Cadillac. That's the mechanical drawing that Delphi Packard would use to make a wiring diagram. It's all the systems. About done, or we need a bigger conference room here?
Simmer down, simmer down.
Okay, well, slow down. He's running out, finally. Wow. And I just looking under, it's upside down. All right, well, it's not for me from this perspective. Steering wheel control integrated module. Here is the right rear door passenger module. Here's the left rear door passenger module. And wiper system, we know how to work on those. Theft deterrent, that's a challenge. Occupant position, that's the pods for the airbag. And on and on and on, my goodness. What are we into here? PCM, and we got, looks like power, looks like a BEC, bus electrical system. What do you got, Mike, in front of you? Lighting. Got mirrors, interior lighting. You got the exterior lighting. What do you got down there?
Brake tires, wheels. What else we got? Cellular phone.
Yeah, these are just what it takes to make all these subsystems all hooked together in a car. So that's why obviously we got to have multiplexing. We can't have wires to all this stuff. You guys want to roll it back up now? By the way, if you turn it upside down, it's perfect for weddings. All right. Thank you. All right, let's get busy here. And I want to get you guys' names. I want to give away a prize here already. We're going to auction some of this stuff off also, but I'll show you what the prize is for while they're wrapping that up. You know, to do multiplexing, I don't know why this HP assistant comes up. If we have an IT person in the room, feel free to help me out at break time. Turn that off. But, you know, a lot of you guys are buying stuff from Bernie back there and, you know, all kinds of really cool diagnostic equipment. I'm telling you, you don't need it. We're going to be giving you... You don't need any of it. We're going to be giving away for these guys that help me out. Make sure you tell me your names and your addresses at break. And you guys can, the rest of you guys can buy some on auction here this morning. The ultimate diagnostic equipment.
You've spent thousands on expensive diagnostic tools and the training to use them, but no more. Introducing the revolutionary Diagnostic 8-Ball. Now you can produce professional diagnostic results at a fraction of the cost. This technological breakthrough can be yours for the low price of only $19.95. Don't waste time and money sitting through boring training classes. Use the Diagnostic 8-Ball's included easy instructions to get the job done and the car out the door. But you can only get your Diagnostic 8-Ball through this special TV offer. So don't delay. Order today.
The Diagnostic 8-Ball saved me thousands of dollars and a lot of time. Thanks, Team AVI.
Why get behind the 8-Ball when you can own it? Call the number on your screen for rush delivery now.
Okay, I think these guys deserve an 8-ball, maybe a hand for helping out here. All right. Okay. Sorry, Bernie, but there's something better now than what you've got back there. Okay. Let's go ahead and start this this PowerPoint and page, what is it, 1-1 or something? I got to get my book and follow with you. And get my little high-tech cordless mouse working. There we go. Somewhere I laid, here we go. All right, Fred, which you guys know the story of Fred, right? If you've had the class, I always tell the story. I started working maybe, I don't know, at Delphi 12 years after the Fred engineers came along. They wasn't called Fred engineers there, they were called ED engineers, electronic device. The ECM hadn't been given a name yet. This is in the 70s. I came to work in Delphi in '89. Prior to that, I was a tech in my dad's auto-electric shop and worked there into the 90s, really, part-time until I finally gave it up and went into teaching in my spare time. But yeah, in the 70s, they had this electronic device and was going to do all these gee-whiz stuff, you know, to make the car get stoic going down the road under as many circumstances as possible and get good emissions. And they gave the plans on what this thing was going to do and how it was going to be diagnosed. They gave those plans to the service engineers, and that's the group I work in at Delphi in Kokomo, Indiana, at the Delco Electronics plant. Now it's called Delphi E&S, Electronics and Safety, because we inherited the airbag group out of Ohio. And my group actually in the basement of the building that does service, we do the remanufacturing, things like that. We're called Delphi Product and Service Solutions. We're part of a bigger group that does aftermarket. My particular group supports the original equipment people. I get dealers on my hotline all the time. And our service engineers, at that time, it's called Delco Electronics. They got the plan for ED and they renamed it RED, Ridiculous Electronic Device. And then when the check engine light started coming on in 1980, and many of you older guys remember this, you re-nicknamed it FRED, which stands for Frustrating Ridiculous Electronic Device, right? I know what you were thinking. Okay. Page 1 gives you, there's my name, Dave Hobbs. Okay. There's information on it. You can bug me if you want to. It's not really a bug. If I'm in a time where I'm not busy, I may get back with you in an hour or two, or it might be a week. So give me an email. You can call that's my cell phone right there. Don't call me weird hours or Sunday mornings. I'm in church or something, but or on the radio, actually. I do radio broadcasts Sunday mornings, too, on local radio station. There's my cell phone number. There's my email. That's my website, by the way. You can go to my website, and there is, and I'll talk about this later in the program, there is a, for dealers only, instructions on how to unlock the old Delco radios. You may run into those. You don't take the battery cable off to do some service, and you hook it back up, and it says lock prior to 1999 or 2000 or so. There's instructions on how to unlock those there. For dealers only, okay? All right? Yeah. All right? Nobody wants to steal the old radios anymore, but more on that later. But that's on my website, so there's information on me. Roman numeral 2, this is going to be our map this morning. We're going to do a multiplexing overview. We'll talk about some of the older stuff that's still kicking around. You know, UART's still on cars, and you may use some dedicated UART stuff to go between a TAC module and a PCM, even though everything else is Class 2. And then, of course, CAN buses, Keyword 2000, GM LAN, high speed, low speed, all that kind of stuff in multiplexing overview. And then what BCMs do and don't do. Discrete I/O, digital I/Os, there's some misnomers. People say that the brake pedal input is a digital input. Well, technically, we like to call them something called discrete. We'll get into that if you don't know about that. And now the brake pedal is actually analog. Power moding, wrap operation, vehicle battery rundown protection, load shedding, and we might even touch on RVC, regulated voltage control, if we have time. Vehicle theft deterrent, the VTD, is integrated into a lot of BCMs. Fail soft and fail safe, flashing versus configuring, and some case studies and diagnostic tips and so forth. So we got 10 chapters. Try and get through here in about 3 hours or so. And first off, page 1-1, what the heck is a serial data bus? It's just a wire. It's not a component. It's a wire to get information from one module to another, one thread to another. And it basically works like Morse code, only instead of dots and dashes, you know, it's flat spots and rise spots on a square wave. And other modules monitor this data bus either for information or they carry out commands and so forth. Now, in the old days, dating me, you used to have to put a resistance through the scan tool of 10K. They called it 10K mode. And the terminals were L and M. Back in the old 12-pin days, L and M, and I don't know if you remember those cars that were like the GM30 cars, they called them. They were the old Rivieras and Eldorados. They had a little different cover for the old ALDL, and it had a little shorting bar in it, like the shorting bars we used to use to pull codes shorting A and B. And they would short two terminals, L and M, together. We'll talk about loop configurations. That was early days of loop. And then you would put with your scanner, when you unplug that cover, which is supposed to have a little plastic tab like a gas cap to keep it from falling off, but it usually fell off anyways, and or got pulled off. And you would put 10K, which would tell that ECM to start communicating with the scan tool. You don't do that anymore. Now the scan tools are bidirectional as far as communicating. They send a signal. They say, I am either the mode master in some older buses, or I am a node. I am a member. I'm a fellow Fred. Please talk to me. So that's going on with just signals now instead of dropping voltage. The old bus was called UART, which stood for Universal Asynchronous Receive and Transmit. Receive and transmit is pretty easy to figure out, right? It talks and listens. But the universal, well, that's pretty obvious too. It's universal. But the asynchronous, synchronous versus asynchronous, as far as there is no clock pulse. A lot of buses and some electronics have a clock pulse for signals. They don't use that as a separate signal or wire on this bus. So it carries its own series of pulses. It's around 5 volts. By the way, you know, P codes are powertrain, C codes are chassis, B codes are body, and U codes are I would think it'd be a C or something, right? Or a TX, maybe transmit and receive. Where's the U come from? Could it be U for UART? Because that was the original bus for GM. So when they came out with U codes, I think they just used, this is my theory, I've never had anybody actually deny or confirm that, but I think the U is for the old UART. That's how you can remember what the U codes are. So we'll talk about U1000s and 1255s and 1064s and all that kind of stuff this morning. All right, when a module wanted to talk on the UART bus, the bus was normally high, meaning you had to have key on. And when the device wanted to talk, it would pull that bus down to ground and make the bottom of the square wave. There's a new DLC, you know, OBD2 and newer. Yeah, new like, what, 11 model years old. And there's the lineup, at least for GM. Pin 1 is the low-speed LAN, single-wire bus, the new GM LAN, a version of CAN. The Pin 2 is still the J1850. GM calls it Class 2. Guess what's in there in a Chrysler? J1850, called PCI. And Pin 3, discretionary. I believe Pins 3 and 11 on Ford are MS CAN. MS doesn't stand for Microsoft, stands for medium speed CAN. And then there's pins 4 and 5, which are your grounds, and pin 16 down here, which is your power. And keyword, that you need to put a 0 there. I have a typo, and this handout and in the presentation too. Put a 0 after keyword. KW stands for keyword, and it's not 200, it's 2,000. And we'll get into how that works in a minute too. And what else we got? Discretionary, pin 10, another J1850 bus. J1850 buses are not necessarily the same. You'd think they would be. You know, J, that means it's what? Either Kent Moore or SAE. So either going to cost a lot or be confusing, okay? So, you know, J1850, the SAE standard for OBD2 diagnostic, you know, serial data buses, for Ford is a 2-wire bus. But for Chrysler and GM, it's a single-wire bus. For Ford, it's pulse width modulated. For GM and Chrysler's, it's variable pulse width. So that's supposed to be a standard, the same number, just like J2534 is really standardized, right? If you guys are flashing, it's like, oh, geez, got to have the right Java. I need some Java right now. Okay. Keyword L-line, keyword pulse, unswitched. Let's see what else that's about it. That's the whole DLC. All right, next page, 1-4. SAE also said we're going to have the buses grouped into 3 types. Class A, Class B, Class C. All you got to remember is the bigger the letter, the faster the bus. The Class A was UART, which was typically the 8.192. All the early ones talking about baud rate. Now, baud rate, think of your modem. Everybody knows that, right? Everybody knows that now most of you have cable or DSL. Anybody still dialing up? My dad lives out in the country. He still dials up. Anybody still dial up at home or anything? My dad is the only person in the world, I think, that still has dial-up. He could get a satellite, but it's like $70 a month or something. He didn't want to do that bad. But he's still an IE10 guy. He's 77 years old, and he gets on IE10 and helps guys out. That's pretty cool. But you know, I can remember the modem days of, was it 14.7? So basically, you know, you logged on, you went and actually brewed a cup of coffee and came back and you heard, you've got mail. Well, now we're looking at 56 kilobaud for dial-up. That's 56,000 little ones and zeros per second. And this is down the UART, and before that, UART, 2 speeds, was down at 160 baud rate. When they first came out with computers, you had basically 1.2 seconds between serial data updates. Remember those days, guys? Some of you older guys? And then they went to about every 200 milliseconds there was an update. So about 5 times a second, the old Tech 1 would be updating RPMs, TPS, whatever. And that was not quite as good as having a scope, but it was better than once every second and a quarter or so. And Class 2 was actually just a tad faster. So I think technically it's in the Class B rating, medium speed, which is 10.4 kilobaud for Class 2. It was 8.192 or 8192 for UART. And when you go into programming mode, Class 2 goes to 40 kilobaud, all right? The GM LAN low-speed bus, a single wire that makes things talk to each other that don't need really super high speed. You don't need the BCM to tell the radio to make the chimes and alarms in real-time figures, like cable modem speeds of 500 kilobaud. You don't need that. So that's on the low-speed bus. It's a simpler, cheaper bus. And medium speed CAM, MS CAN, that's what Ford likes to call their system. It's also used for non-powertrain and chassis stuff. That's a Class B bus. And then Class C buses are the super fast stuff, 125 up to 500 kilobaud. In fact, some systems can approach a meg. So that's getting fast. That's even faster than your cable modem at home. With that, there are issues we'll talk about as we get into the class. Now, why am I giving the A, B, and C? Well, it's an SAE standard for bus speeds. And you might also see like CAN C in some other, GM you won't see that, but I've seen that on Chrysler, CAN C, and they call it the diagnostic bus. So it's a real high-speed bus. All right, we've talked about the evolution really already. The UART days, 160 was the mid to early, tailing off in the late 80s, and then the late 80s into the 90s, the higher speed UART We had E&C in here throughout the 1990s. You may even see it in a few early 2000s if you're working on maybe an audio system in a 2002 Suburban or something. That's still using the E&C, and we'll go into the voltages and stuff you have in all these. Class 2 is actually still around. It's right there in your shop. A little CAN is starting to pop into your shop pretty regularly now. It's 10.4K, the Class 2. CAN, as we said, up to 500 kilobaud. Every time you make a speed change, you can get more data to your tool, which is good, or to other modules on the vehicle, which is good for the customer. And there's some early applications starting to roll out. 04 Buick Rendezvous, some Cadillacs, some Saturn Ions. In fact, I had a guy that had a class. I went out to visit some friends in Arizona, so I did a class in Phoenix and Tucson in January, on vacation, and at the Department of Transportation in Phoenix. And this guy named Ernest Servin, really nice guy. He took the class. He missed my class in Vegas at Cars, so he came out. He lived in Phoenix, so he came out to the class there. And he calls me, or gives me an email here this week, and he says, you know, hate to bother you, but I've got this 2004 Ion, and there's no power steering. And he thought it might have been a data bus problem. And he had a U1000 in the cluster. Well, at that point, having a U1000 in the cluster and no power steering, you know, maybe it could be data bus related or not. But one thing he couldn't do, he couldn't communicate with the electric power steering module. Now, he was using something I'd never heard of yet. It was a brand new Snap-on scanner called the Ethos. Has anybody got one of those yet? Is that how you even pronounce it? Ethos. Have you heard of it? Is it a code reader? Is it a true scanner? What is it?
Code reader.
It's just a code reader.
It's a collection device.
It's entry level.
Yeah, basically.
This is entry level Snap-on, so it's $8,000 then.
No.
Okay. All right.
Not quite.
Well, it ought to work. It ought to communicate with everything. As we get into this class, you're going to think I'm selling V-tronic stuff. Believe me, I work at Delphi. I would like my full-time paying job with benefits to remain. We're in Chapter 11, so it would be good to make profits. And guess who owns V-tronics? Bosch. They're a competitor. So I hate to tell you, you know, to go buy that stuff, but it is the only, not the Master Tech, the Tech 2, and soon to be the, I forget what the acronym. Yeah, thank you, MDI or whatever, that new laptop-based systems. Anybody got that yet? Any dealers in here? Got any dealers in the room? One dealer? Okay. Well, I know you. I can still slam dealers in. Okay, you'll forgive me. All right. Anyways, the V-tronics Tech 2, it's the only way to fly. Let's see a survey. Who's got a Tech 2? Excellent. A good, about a third of the room, would you say that? About a third of the room. Okay. All right, let's talk about binary. Binary, a lot of you guys know this already, so some of this is just early, get out of the way, review stuff. It is 1 and 0, that's how you count, 1, 0, 1, 0, 1, 1, and so forth. You can take a base 10 number like we use, you know, a number like 418. You can take that number and you can turn it into binary. It'd be a bunch of 1s and 0s. You can also turn it into something called octagonal. Is that how it's said? I never see that in the computer world, but hexadecimal, I see that. If you get one of those $20, you don't need to figure out your kid's graphic calculator, by the way. Don't even try to figure that one out. Let them use that for trigonometry and hope they get a good grade. They don't ask you any questions. But get the $20 Walmart scientific calculator without the graphing screen, and you'll have buttons on there to convert regular base 10 numbers into hex or binary and back the other way. And I think, Doc Null, you're going to be covering mode 6, so there's a lot of hex stuff in there, right? Yep, lots of hex. Okay, so binary, 0s and 1s, and when you have a signal like that, when the signal was low, it was 0. When it was high, it's 1. If it was low, 2 periods of time, and those periods are 128 milliseconds. What's 128 times 2? 256. Is 256 a magic number? Well, you could get 128 on your old block learn for years, or you can get 128 on your program number on automatic air conditioning. You could also get 2 something. It seems like in a lot of counters will go up to 2 something and quit and start back over again like a camshaft position counter. That's 2 bits of data in hexadecimal, the biggest you can get is FF. Now, the biggest you can get in binary is 1, 1 or whatever. But the biggest you can get with 2 digits of base 10 would be what? 99. But the biggest you can get with 2 bits of hexadecimal, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like base 10, like we count, and then A, B, C, D, E, F. So they actually have some letters and numbers. If you get 2 digits of hex, what's the biggest number you can have? FF, which in base 10 is 256. So 128 milliseconds, it's a 1. But if it stays 128 milliseconds on, it's basically 2 ones. That was UART. It was not a variable pulse width bus. All right, let's keep going. There's a 7 volt, and that's down there is wrong. Make a big X across that. Because when it's high, 2 periods of time, 228 millisecond periods of time, it actually becomes a 0. Let me change the next page, 1-8. There we go. Class 2 is different from UART in that we can vary the pulse width. I want you to write this down because it's not in your books. Variable pulse width, VPW. And that's what Chrysler calls their single wire J1850 bus, VPW, variable pulse width. They vary the on time not to necessarily turn the state off and on, but to turn the bit, to make the bits change. The number of bit changes we get is the number of information changes we can get. It's confusing. Now don't necessarily call it pulse width modulated. In fact, you can make an X across there. I'm calling it pulse width modulated. It's not pulse width modulated per se, like a dash light or something like that, or an EGR solenoid. It's a variable pulse width. All right. Okay, let's get to something tangible that it's more practical. Let's talk about how these modules are laid out because that dictates how you diagnose problems with the data bus. If you had a BCM and a PCM and a cluster, radio, and an airbag, we're on page 1-9, and an ABS module, you could hook them all together like, I need a table with a bunch of guys that make a complete circle. You guys up here, okay? Would you be so kind, in the interest of everybody understanding how this works, to all turn facing the center of the table? Now everybody hold hands, all right? We're not going to say grace, okay? We might at lunch, but okay. Now, how many hands are you holding, Phil? He's holding two hands, okay? If Phil wants to talk to Bob over here, and Phil drops this guy's hand, go ahead, drop his hand, okay? Can he still get a message over to Bob if he's using handshakes to send a message?
Yes.
Certainly, he goes around this way, all right? Now, if Bob drops his hand with Dave, go ahead. Now, can you communicate to Bob?
I don't think so.
Bob's off the bus, this guy's off the bus, everybody else is still on the bus, okay? But the problem is, if the bus is shorted, let's say, is it Dave, right? Drew over here decides he's going to screw up the whole thing today and short the bus to ground or to power. Now who's to blame? How do we know? All we know is we plug into the DLC and we look at resistance. You can go ahead and hold hands again, okay? I know you wanted to anyway. All right. All right. So if Drew's over here shorting the ground, how do I know who's doing it? I put my meter over here at some spot like pin 2 of the DLC, and it just shows, 0.2 ohms to ground. I don't know who it is. There's no place where I can disconnect you all. So I have to, one at a time, pull you guys off the bus. There you go. Unplug. All right, did the short go away? No, it's still there, okay? And go to the next guy. That's a lot of R&R, okay? That's the problem with a loop configured bus. But the nice thing about it is it's more reliable. You guys can turn loose now. All right? Now, thank you. Yeah, they're glad. All right. One guy's going, I got to go wash my hands now. All right. All right, what happens at these ATTF seminars stays here, okay? All right. Okay, here we go. Loop configuration. There's the real vehicle. They were going to sing Kumbaya in any minute, I could tell. All right. There's an RFA, there's a BCM, we're on page 1-10. There's an EBTCM for your anti-lock brakes. There's a powertrain control module. There's a ride control module. There's a radio amplifier. It says radio interface module. Oh, I hate that when they do that. You guys ever mess with a rim? Who's ever replaced a rim on a car? RIM? Okay. What was you fixing, sir?
This is 07 Tahoe.
07 Tahoe.
Yeah.
I bet that rim meant something else.
Yeah.
It was a body control module, wasn't it? Something wasn't happening?
They ran over something
Okay.
and it bent the rim.
Oh, bent the rim as far as in wheel rim. That's an RIM too. How about a acronym rim? Rear integration module? Have you replaced one of those, Mike?
No.
You're wanting to. You mentioned in class. There's two uses, but three now. There's a rim, like, you know, the cool rims the kids are putting on cars these days. RIM. There's an acronym. RIM. Two of them. Rear integration module, which really what we're going to talk about today. And then this guy, which is also on the data bus, called a radio interface module. What's the difference? Does anybody know? Tell me. What's the difference? Well, obviously they're different, but what is the difference? One's a body control module. The other one is an interface module between a non-Class 2 Bose amplifier and a Delphi Class 2 radio. When you turn the volume up on some of the late 90s, early 2000s Cadillacs, for example, when you turn the volume up, you're not sending more volume to the amplifier. What I mean by that is more amplitude of preamped signal. You know, the audio's not amplified yet, so if you put a scope on it or an AC meter, you'd see a little bit of signal. It wouldn't be near the signal you'll get out of the amplifier going to a speaker, obviously, because it's not amplified yet. But you'll actually increase that preamped signal when you turn the radio up on most cars. On this Cadillacs, you send a Class 2 message that says, turn the volume up or fade to the left. And that information, the dumb Bose amplifier can't do anything with it. So we have this module that's between the radio and the Bose amplifier that does that. It's called a radio interface module. Confuses the heck out of you. You see that, you think it's something to do with the rear integration module, which, Mike, that is something to do with the the body control stuff. You know, turn the rear defogger grid on. It's the equivalent, it's the passenger car equivalent of a liftgate module. Because that does double duty. It just doesn't pop the glass on an SUV. You know, it's the keyless entry antenna receiver, and it controls the heated glass and all that kind of stuff. So the liftgate module's got double duty. Rims do all kinds of stuff. They basically break the BCM up into three pieces. More on that later. But that's confusing. I wanted to bring that out here in the point. Loop configuration, each, like we did in a little demonstration over there, each module has how many wires going to it? Two. Are they in series or parallel electrically? You know they got to be in parallel. Like series, like that rust between this is dating me, the rust between the ground and the wire to your fuel sending unit. And that was in series, wasn't it? And what'd that make the fuel gauge show? Fuller than normal, right? Oh, I ran out of gas. So that's in series. When you put something in series, you're dropping voltage, you know, each along the way. That's not how those were hooked up. They may have been holding hands and looking like they were in series, but actually, through each module, there was a trace right through the circuit board. So it was just like they were all in parallel, but they had two wires in parallel on that trace, okay, or on that circuit. So loop configurations in parallel, but you had to have two opens, like we showed here, in order for communications to be lost. That was the good news. Bad news was we had to disconnect each module one at a time to try and find out where the short to power or ground was if you had an issue with that. Okay? And difficult to isolate, we talked about that. Here's the next one. What are we on? Page 1-12. And they do this in the computer industry. Not being a computer expert, I can't even get that HP Assistant off my computer. It's going to come on any second now. But they hook stuff up together in a star configuration. It actually kind of looks like a star. On the car, it doesn't. The car looks like a bus bar to me. But for this picture, we show the PCM, the BCM, the HVAC, the radio all coming together at one point. Actually, it looks more like this to one little strip. an SP splice pack. There may be one, there may be two. They may both be under the IP left side. There might be one under the left IP, one under the right IP. The most popular place I see these little star connectors, AKA known as the comb, looks like something you comb your hair with, if you had really small hair, is that they are right near the DLC. You find the DLC and just start pulling some of the black tape off and going upstream a little bit, you'll find this splice pack. Who's found these splice packs before working on this? Good, several of you guys. All right. Those things are ideal because basically those things are like, if this is the splice pack right here, how did you get that in here? Man, these guys rolled that up tight. Super. Okay, can we guys, you want these guys to do it again? They're not going to hold hands this time. All right. Everybody grab this pipe. That is your shorting bar. That's your splice pack. That's your comb, okay? That's your SP30, whatever it is, okay? Now, if somebody shorts the bus, Drew's going to short the bus again. That's what he's been doing all morning, all right? He's shorting the bus to ground. Nothing's going to work. The scanner's going to say no data. You're going to think, daggone snap-on scanner, whatever. It's not doing the job. So what you can do is go to the DLC, measure it. Oh, man, it's 0.2 ohms to ground. Remove the splice pack. Keep your hands out there, though. Remove the splice pack. Now, nobody's hands are touching. I know you'd like to touch, guys, but don't touch hands. Okay, there we go. Nobody's hands are touching. They're all isolated. Now, I look at the connector, the DLC, and it says good. So now I go to each wire with my ohm meter. Oh, that's 600 ohms. Oh, that's 3,000 ohms. That's 9,000 ohms. 0.2. Oh, it's the Drew module again, all right? Thanks, guys. Drew module shorted out again. Okay. Yeah, go ahead. You guys were doing such a good job. Because they're efficient. I'll probably never get it out of there. All right. So there's star configuration in a real schematic. Page 1-14. And it's using two splice packs. What are they called? SP205. By the way, did you know how things are laid out in GM schematics? I would assume everybody's like this, but I got to confess, for the first 10 years of my Delphi career, when it was Delco Electronics, we were General Motors. And before that, there were basically three kinds of cars that came into my dad's shop. There were Ford, Chrysler, and GM, and about 80% of them were GM, and about 15% were Chrysler, and the other 5% were Ford, because we are GM town with a Delco plant there. And we also had Chrysler there too, but we preferred not to work on them unless we had to. And we only worked on Fords if it was something simple. So I just got it in my blood. A lot of AC Delco classes were a real blessing to me growing up. You know, into my teens and my 20s and 30s, you know, going from Cincinnati, from Kokomo, Indiana is not that far of a trip, and they always had good training. And so I'm really GM indoctrinated. I'm just starting to get out of that rut, and because we have like 19 out of 20 supplier, or we are a supplier, we as a Delphi are a supplier to 19 out of 20 of the major OEMs. And everybody always asks me, who's the 20th car manufacturer that doesn't buy stuff from you? I don't know. Maybe GM soon, I don't know. Anyways, in the GM schematic world, what are the 100 series? P's for pass-throughs, which is another word for grommet, C's for connectors, SP's for splice packs, G's for grounds. What are the 100 series? Where are they located? Huh? Front of the car, under the hood typically. And what are the 200 series? You work your way back, bulkhead, firewall, okay, IP area. The 300 series, passenger compartment. The 400 series, open the trunk, we're in the trunk. What's the 500 series? Left front door. 600 series. Right front door. 700 series. Left rear door. So the odd numbers, 500, 700, that's your doors, left side. And the even numbers, 600, 800, is your right doors, front and rear. What's 900 series? What if you had a G900, G901? SUV hatch. SUV hatch. So that's some of those things to kind of decode where things are, in case your Mitchell on Demand forgets to tell you the location of a G901 or whatever. And here's all the modules. We got cluster and steering column lock module. What vehicle must this be if it's got a steering column lock module? Corvette, very good. Radio amplifier, looks like a memory seat module, vehicle control, vehicle communications interface module. What must that product be if it's a VCIM? OnStar, good, all right. What's a VCU? OnStar. The VCU is the phone part, and the VCIM is the bus part. It's what gets on the bus when the OnStar people, you call them on your cell phone, you say, I did it again. I locked the keys out. So they call your VCU after you give them the PIN number, which is the phone part of OnStar. The VCU connects to the VCIM on newer OnStars. It's all one box. And the VCIM, Vehicle Communications Interface, the word interface, is a gateway on various buses. If you need the horn honked, and I've done this before, I called OnStar up, and I literally could not find at the Indy 500 the Cadillac that I'd borrowed from Delphi to go down there. And I go, wait, it's got OnStar. I'll have them honk the horn. You know, because I'm not close enough to my keyless entry to work, but the cell signal is always close enough. So through the cell tower, here comes an OnStar signal. My car wakes up, and it starts honking 300 yards away. I go, there it is. The lights are flashing, the horn's honking. Whatever bus that model year Cadillac had to get on, the OnStar module had to get on that bus and have that item start doing those things. That means the OnStar modules can oftentimes be something called a gateway. More on gateways later, but just remember they're on more than one bus. They're like a translator. Okay, 1-15. There's a hybrid. I don't mean hybrid as in electric/gas engine. I mean hybrid as a combination, like hybrid seed corn. You guys have corn out here in New York? That's about all we are. Corn and cars in Indiana. And you have a little bit of star connection here. There's a splice pack. And you also have some loop configurations. There's a ABS module's got 2 wires each. So if you want to isolate it, you got to unplug it. But those 2 wires, they're not in series, they're in parallel. All right. So there's all the modules that are in both loop and star configuration. So if you want to find out where wow, I got to look on here. There we go. SP300 is, where would SP300 be? Under the hood, in the trunk, in the car, under the dash. And maybe actually a little closer to the, I don't know, it could be under the seat, but it certainly is in the passenger compartment, because 300s can also be under the dash or under the seat. What to do now? If you know how all this stuff works, how it's all wired together, let's say you had a no start and you couldn't get the scan tool to communicate, and you tried another scan tool, that's always a good idea, right? People who have Tech 2s who also, hold your hand up if you got a Tech 2, first off. Let's do that again, all right? Do you also have another scanner? Keep your hand up. And John O'Lello will have his hand up the whole day because he's got every scanner. Him and Linder, they have every scanner known to man, all right? It's a scanner museum. It's a scanner proving grounds, too. The main point, if you have a lab scope, is to see if you're getting square wave. So you would go between pin 2, which is always easy to remember. With GM, it's always, pin 2 is always class 2. Is that easy to remember or what? Pin 2 is class 2. Pins 4 and 5 are the grounds. One's a power ground and the other one is a signal ground. All right? So you go between either one of them with your scope and you see a square wave. You don't see a square wave, you got issues. All right? Put an ohm meter on there with the key off. And if it's class 2, then you need to make me do what else? You can wait till it goes to sleep, or you can just take the battery cable off. Take the battery cable off because modules will talk on the bus with the key off. Now you can use the ohm meter and go between ground and pin 2, and you should see what? How much is the minimum? This is an easy one to remember too. What's your favorite displacement Chevrolet engine in cubic inches? Thank you. I think most guys say 350. There'll be some people say 427. All right. 350. 350 ohms or greater between ground and pin 2. If you've got 200 ohms, bad. If you've got 500 ohms, okay. You'll typically see much, much more than 350 ohms. But that's the resistance of all the mumbo jumbo inside those FREDs in parallel to ground on the bus. So you'll see much more than 350, but 350 is the bare minimum. And here's another point here. The guys that had more than one scanner, you guys had a Tech 2 and 18 others, use the other scanner. I mean, if you don't have a Tech 2 especially, if you got a Master Tech and a Snap-on Genesis or OTC Genesis, try them both. Try another year, a year newer, a year older, another scanner. If you have the Tech 2, there have been occasions where we've have to go back one version of Tech 2 software if you program your own Tech 2 and you don't go to the dealer and have them program it for you because you bought it there, as some people have been known to do. All right, no lab scope, you got a DVOM. I think probably everybody in here has got a lab scope. But if you have a DVOM, there's the code for short to power. You don't want to see 12 volts. What should you see on the DVOM? AC, DC? Would you put it on the frequency on like a Fluke 87 or 8? Now, you'll see a frequency that's erratic because it's a bunch of random pulses. But you will see in DC mode between pin 2 and a ground, you'll see the meter just dancing around, and typically you can min-max it. You may not always catch it unless you go into the fast min-max, what the Fluke 87 can do. You won't always catch it down at 0.1 or 2 volts at ground, and you may not always catch it at 7, and class 2 is supposedly a 7-volt bus. I never see 7 when I measure them. I usually see 5 and some change. But whatever, you should see some voltage fluctuating, but never see 11 or 12. Never see a solid 10 or 11 or 12. You should see some fluctuating voltage that's somewhere in the 3s, 4s, 5s, 6s, something like that. That's telling you, and it's fluctuating, the bus is active. But if you see 0 or you see a high voltage, that thing's shorted to power ground. Power is a U1301, and the ground is a U1300. Anything less than 350. There we go. That's some of the most common problems you'll see on a bus. And the next thing is, well, who's causing that? We talked about how to isolate. We talked about the loop configuration, where you got to isolate a module at a time. And we talked about the star configuration. You pull that star connector out and just check all the nodes. In fact, Kent Moore makes a tool, and I apologize, I don't have their part number for it. But Kent Moore makes a tool that plugs into the DLC star connector. I shouldn't say DLC star connector, the class 2 star connector. So you unplug the little comb, you plug this tool in there, it's got a rotary switch. And now you're connecting to pin 2 of the DLC, one node at a time. One circuit to one module at a time, and you look to see as you turn the little rotary switch which circuit was causing the short. It's for lazy people that don't want to just back probe each terminal at one at a time. But you can actually put maybe 2 modules together, and I've done this before. If you think there is a module that is disrupting communications, isolate them all and say, okay, I've got this one module that I need to have communicating with another module. I got to have my Tech 2 and my PCM hooked together. Or maybe I need my PCM and my BCM hooked together. Just start entering them back together a few at a time, and you will get communications. Like, for example, the radio, it won't turn on unless it gets a class 2 power mode message. More in the power moding coming up shortly. But you have to then have a BCM or at least a PCM with the engine running for the radio to power up. So you can hook those 2 together and forget the remote control door lock receiver and forget the driver door module. That stuff can be left off the bus. You see if what you're working on starts working when you've eliminated some of the non-essential peripheral modules to try and figure out which one of them is messing up the program here. Okay, speaking of messing up the program here, case study number 1, page 1-17A. This is experience I had with a guy, an engineer at Delphi who didn't have any heat. No, actually this is a different story. I had a lot of Trailblazer problems. All right, 2002 Trailblazer, Here's was the case. It acted like it was starting up and shutting down as if VTD, vehicle theft deterrent, on the Blazers. What kind of system do they call that? Pass, not pass key, pass lock. So you got to rotate this little magnet past a Hall effect switch, and if it's the right resistance and a little tamper switch somehow didn't get turned on, you drop the right voltage to what module? The vehicle theft deterrent, which is built into the body control module. So you drop the right voltage to it, and the car thinks, you know, we're okay to fire. We get a fuel enable message to the PCM. PCM's fat and happy. We crank and we run and continue to run. This thing acted like the VTD had a problem because when they foul up, what do? Start and stall right away. It's like you sprayed a little squirt of ether, and that's all you had in the can, and it shuts right off. So we had a clue, and there was no communications with any module. I went to took the scanner, and it's like no data with the cluster, no data with the PCM, no data with the BCM, no data anywhere. We checked for fuel and spark. We're losing it, just like the VTD is seeing the wrong key. Next page, 17B. The bus is 0 volts. Lots of modules in the Class 2 bus. Which one could it be? There's your clue. Aftermarket radio. Do some digging and you find that the radio's been reconnected somewhere else in the car. Do you know why they do that? They don't do it anymore, by the way. Somebody's invented reverse engineered Class 2 in the aftermarket audio world, and they have figured out a way to emulate what the radio does that the vehicle needs. What does the vehicle need the radio for? Why can't I just use an aftermarket radio on some vehicles, some GM vehicles? Yeah, it is a driver information center of sorts. If it has driver text messaging, that's one reason. But let's just say it was a Trailblazer, which doesn't really do any driver text messaging for me.
Volume speed control? Yeah. Volume speed control?
You would lose that. You put a Sony in there, you wouldn't have that speed compensated volume. You go faster, the radio gets louder. I can live without that. I can reach over there and turn it up. I'm not lazy, John. Okay, I want this 900 watt thing that vibrates people next to you and makes them all irritated. I want that in my dash. But what do I lose? Huh?
Steering wheel controls.
The truck didn't have it. It was cheap. Exactly. Very good. Chimes and alarms. Make a note here. Chimes and alarms are oftentimes done by the radio. Now the BCM could have a little chime maker in it, or the cluster could have a chime maker in it. Shoot, they used to have a module that was called a mid-integrated chime and alarm module, a MyCam. You know how you diagnosed them? You shorted 2 wires in the old DLC, ALDL even before that, and it made the dome light flash codes. We'll talk about that later. That was old, but you'll still work on those. But chimes and alarms are now oftentimes done by the factory radio getting the message from the BCM, and it makes the left front door speaker make noise. And those radios, remember, if you ever seen this, did they look like they were off? You turn the key off, you left the headlights on. You turn the key off, the radio looks dead and dumb and asleep, right? You know it ain't. You look at your Tech 2, it's still awake because it's making noise in that left front door speaker. It doesn't need a display on to make noise going boom, boom, boom in a left front door speaker. The display is just a courtesy for you to see the station you're watching, you're listening to. So they moved these radios, the factory radio, they moved that radio somewhere else on the vehicle to make room in the dash for the, the boombox thing. And on this vehicle, they moved it to a compartment where the amplifier is in that vehicle, if you have an extra amplifier, an auxiliary amplifier. And it's in the right rear quarter panel area, like a trim area. They had a window leak from a previous accident and body repair. The window leak caused that little well area in the right rear quarter back in the cargo area of the Trailblazer to fill up with about that much water. In the bottom of that cavity was that factory radio with a long power and ground and Class 2 line and 2 speaker wires for the left front door speaker. And it was all working until the water got in there. So the Class 2 radio was moved back to the back where it got soaking wet and shorted to ground. And it really happened. When the Class 2 bus is shorted to ground, what module can't communicate on a bus? VTD, PCM, stuff like that. So you can have no starts with shorts on buses. And it can be because of aftermarket accessories like aftermarket radios. Okay, let's keep cruising here. We talked about that shorted bus. Well, sometimes a shorted UART bus can sometimes stop a vehicle, and so will a Class 2 bus being shorted. Case study number 2, another trailblazer. HVAC head quits communicating. No cooling. Check DTCs with the HVAC. Look into the cause of no communication problem by doing the simple Class 2 connector diagnostics. Pull that shorting bar off the bus and start checking all the modules. They all can communicate. It's just not a short condition. That Class 2 HVAC head just wouldn't talk. And if it can't talk, what doesn't happen? You can't get a message that says, hey, PCM, I need the AC clutch relay turned on. Now, incidentally, there's a good, what's in my mind here, I want to relay this to you guys. The BCM is sometimes a little intermediary between the HVAC head if it's an old-fashioned HVAC head, not on a bus. Maybe it's a manual system, although that actually is a manual system of some sorts. I mean, it looks manual. There's no digital display on it or anything. It's on the bus. There are other mechanical-looking systems that are not on the bus. When you push that snowflake button to request AC, where does the wire traditionally go? There's an actual wire, and when that wire has not got a variable voltage on it, which we'd call what? Variable, continuous and variable. Analog. If the wire's not got this square wave on it, it's not digital. If it's just on for a period of time, or then off, like when you push the button, we call that discrete. If there's not a discrete output from the HVAC head to the PCM that has the title AC request, how does the PCM know? If the HVAC head is Class 2, you push the snowflake button, what would the HVAC Class 2 module do? Communicate. It would call up the PCM and say, hello PCM, HVAC here. Hey, yeah, how you doing? I'm all right. I'd like the AC to come on. And as long as the PCM said, hey, the RPMs aren't too high, the coolant's not too hot, we don't have low freon or something like that, we're going to run the AC compressor, right? We're going to turn the relay on. As soon as it jacks up the IAC a bit, turns cooling fans on. That all happens. So that's AC request and AC enable. But if you don't have a Class 2 head and you have a wire coming out that's just 12 volts when you push the button, or not 12 volts when you push the button again, that wire could go to the BCM. And a lot of cars, beware of that. They're starting to move, because what's closer? The PCM under the hood or the BCM under the dash to this guy if it's a non-Class 2 head? Under the seat, yeah, or under the dash, the BCM's there. So just run a low current signal, discrete signal, from the HVAC head to the BCM. If it's a dumb head, a non-Class 2 head or non-LAN head, and the BCM can then turn that discrete input into a what? A Class 2 message or a GM LAN message, and then it can broadcast it through the bulkhead right out to under the hood to that PCM. The PCM sees that request from the BCM. So knowing how these things are laid out, always read the description or theory of operation or product description or whatever, all you can before you even lay hands on a vehicle. Find out, and hopefully they got that spelled out. And so in this particular case, we check for codes. The PCM has no code, has a code for communications with the HVAC. And let's see, what is that code? What is the code? A U, right? It would be a U code. Let's see, no communications with the PCM is a U1016. So if the HVAC wasn't seeing the PCM, it would be a U1016. Every code's going to be a U, and then the next 2 or 3 digits at the end of the code will be the ID for that module. The BCM is 64. The airbag module is 88. It's all in the service manual. You don't need to write it down if you don't want to. Let's see. HVAC is, I don't remember what the HVAC is. But they all have a different code. And if you had a code in the PCM that said U whatever it is and you looked it up, that's HVAC, is the PCM bad or the HVAC bad? Let me ask you this. If there's a U code in module A, the Dave module here, if there's a U code in module A, is the Dave module bad? Now, it's usually the Paul module, or the Leo module, or the Billy module. It's never the module with the code in it, almost never. He's saying somebody is supposed to be here on this bus and they're not reporting in. Okay, Freds like to hear from one another. That's what I'm talking about now. They send out SOH, state of health. That's what that stands for, state of health messages. Every so many seconds, there's a message that says, I'm the Paul module, and I'm on the bus, and I'm okay. And all the rest of them see that. Now, does the Dave module always care, though?
Hell no. No one cares.
Yeah. Okay, if the Dave module is the radio, and the Paul module is the BCM, they have business together. But the Billy module is the, let's say, the airbag module, okay? And the airbag modules, they care about the radio. There's no business. There's no need for the radio and the airbag module to have communications with each other. So if the airbag module dropped off, the BCM, I can't remember who's the BCM. He's the BCM and you're the radio, okay? The BCM wouldn't care, the BCM would care if the airbag module dropped off, but the radio wouldn't care. So you wouldn't have a U10, a U1128, which is no radio communicating as a BCM, but
It's BCM.
he was a BCM. Yeah. So the radio wouldn't have a U1128 saying, where the heck's the airbag module? That's actually a 1088. 1088, a U1088, you would not set a U1088 because you don't care about airbags. So
He's too old and slow to use that much. You're gonna get us all killed.
by the way, speaking of old and slow, you know that when we get into GM LAN here in a few minutes, GM LAN is a higher speed bus, right? You guys know that? We talked about that. Which modules would be on the high-speed bus? We know we talked about the powertrain controls would be there. What else would be needing to talk real time? ABS. Somebody said airbag. Old and slow, all right. I'm sorry. And you gave me a good tech article this morning, and I'm slamming you. All right. The airbag module, you would think, would need to be on the high-speed bus. Does it deploy the bag with a data bus signal? Let's hope not.
Yeah,
Let's hope we have a sensor and a transistor and some good old wires to go do that. I don't want to have to send a message and hope it gets through. So the messaging for airbag modules is strictly for diagnostics, for your Tech 2 to get in there and pick its brain to see if it's a clock spring coil that's open or whatever. So the airbag module is actually on the lower speed LAN bus we'll be getting into. And the ABS, you're right, traction control, ride control, power steering, and the engine, all that stuff's got to talk real time, really fast. So those being the high speed. There we go. All right. Can somebody help me? Gosh, I told you it would do this. Okay. Oftentimes you need the Master Tech or Tech 2, at least the Master Tech, if not the Tech 2, to get certain codes. As a matter of fact, realistically, who's got a Master Tech? Several guys. Good tool, great tool. It is an edge, in my book, just an edge better than some other tools, but it's no ways near the Tech 2 also in some aspects. It is not a Tech 2. It is not a replacement for the Tech 2 in the body control world. Does a great job on powertrain, and like a Snap-on or OTC can do some things in the body world. For example, it can't unlock a radio. There's certain things you just can't do anything any way around a Tech 2. All right, 1-20, we talked about the PCM needs to hear from the HVAC and vice versa because they have business on this bus. but the whatever else, the airbag, if you had an airbag module over here, the ABS module may not give a care about the airbag being there or not being there on the bus, reporting in. U1000s are generic codes, as are 1255s, and they are a lot like, I compare them to, who was in Boy Scouts, all right? Who was in Boy Scouts? Boy Scouts in here, all right. Patrol leaders? Patrol leaders, you're responsible. Don, you're a patrol, were you a patrol leader? No, okay, all right. So much for that theory. Okay, who was a patrol leader, anybody? Bunch of slackers. Drew was a patrol leader. I'm not going to use you. You short the bus all the time. All right. So Drew's a patrol leader in his Boy Scout troop. Means that this group of scouts is in his patrol. You're going on a hike, okay, up in the mountains, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, including yourself, going on this hike. 9 modules, if you will. 9 scouts on a hike. One of them notices when he gets back, the patrol leader says, guess what? I only see 8 heads here. One of us is missing.
We Steve's, we don't care.
They don't care. All right. That would be a U1000. I don't know who's missing, but somebody is not sending a state of health message. And would be a learned node. A learned node is basically this Boy Scout troop. Now, there may be other modules. You maybe have 20 modules, 20-some modules on some Cadillacs that are on the data bus. So here's a group of modules over here. Maybe it's a bunch of powertrain stuff. You guys are a bunch of body control stuff, okay? Lift gate modules and driver door module, memory seat modules, all right? One of the body control modules, you learn that these guys are in your network and they're important to you. One of them doesn't report in, you set a U1000.
Is that each key call?
Each key cycle.
Each key cycle.
And continual.
Okay.
It updates continually. However, we may not care over here about an ABS module. So a radio might not set a U1000, doesn't see the ABS module. But it would set if it didn't see the BCM. So that's the U1000s and U1255s are generic code losses. When we see something specific, that's page 1-21, we see something specific like a 1016, you look that up in the service manual, and 16 is the PCM. So the HVAC's saying, I don't see the PCM. And it sets a code specific to, I don't see that particular module. So you have generic loss of communications, and you have specific to the module loss of communications. All right. This is really important to remember. The module with the loss of communication code set in it is typically not the module to replace. I can't emphasize that enough. All right. Here's the deal where you can set some U1000s or U blah, 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 specific code, loss of communications. Configure the car incorrectly. We'll talk about configuration a little bit later. We get into the BCM part. But when you get a new BCM, you got to take your Tech 2 and you got to set it up. And you got to tell it, it's in this country, and it's got Twilight Sentinel, it's got daytime running lamps, it's got this, it's got that. It don't have this, it don't have that. And if you set that up improperly, you will set one of these U codes in various modules. You will cause the code to set. So you got to make sure you find that RPO code sticker somewhere on that car, and you decode those RPO codes, and you make sure exactly the equipment on the car. Do you have OnStar? Well, how do you tell? Well, typically, the 3 buttons on the mirror. Other things aren't as noticeable. Do you have remote keyless entry? I don't know. The customer gave me 1 key on no ring, so I don't know if there's a fob and they're just holding out on me, or if it's just a key and they don't have a key fob, it doesn't have remote keyless entry. You got to look it up and find that equipment, and if you got it, you got to configure the new BCM with that, or if you don't have it, don't configure it, because you'll get a code set in various modules saying, gee, I don't see, and I did this. I took a rental car, and my Tech 2 always goes on vacation with me, and I went to this Pontiac G6, and I go, let's reconfigure the BCM. This will be fun. And I reconfigured it to have ABS. Prior to a year or two ago, sometimes I feel like Rip Van Winkle. I don't go to a class for like a month or 2, and I just feel like I just went to sleep and woke back up 100 years later. I'm so behind. When did they quit putting ABS as a standard feature on GM cars? Man,
No, they did.
was it a long time
I
ago?
have no idea. I didn't know they did.
It's not a standard feature. We got a whole fleet of cars at Delphi. They're rentals, and we tear them up and put stuff on them when we restore them. You know, if we have to buy a whole new IP, we buy a whole new IP, and we think they know what we're doing with them. But anyways, the rental car companies that rent us these cars, they don't have any ABS. I was doing a class last week with the engineers. That's one of the things I do besides hotline troubleshooting. Engineers, we teach them bumper to bumper how cars work. They need it, right? Yeah, and they can say amen like we're in church anytime you want to. They really need to know how cars work, and they really do want to learn, by the way. And I really do make them take the back plug out on a V6. And we're trying to do ABS, you know, do a demonstration. We went to 3 different engineering cars because we don't own cars anymore because, you know, that's the new way, you rent them. And so we have this fleet of rental cars. We went to 3 different rental cars, high-end stuff. I mean, it had deluxe this and that. No stinking ABS. Well, I wouldn't buy a new Impala LTC with a sunroof and all that junk without, and a V8 with displacement on demand without ABS, but they're coming through that way. So you can configure, and I did this with the rental car recently. I took the BCM, reconfigured it to have ABS. Guess what? The ABS light came on. Yeah, and there were U codes in various modules that care about ABS. Now the radio didn't have a U code for the ABS, but the BCM did, the PCM did, so forth. And of course you go to communicate with the BCM, with the ABS module, and guess what? It says no communications. But you can't fix what's not broke. If it's not there, you can't fix it. Displacement on demand, there are some GMT 360s, which are like, you know, Rainiers and Trailblazers, that have the displacement on demand, the manifold, you know, that goes between the heads. It has it, but it's not hooked up. It's just the harness isn't there. They had a problem with that model, and late in production, they said, oh, well, I don't care. I don't care if we put the stuff there. We're not hooking it up. It's going to be a disaster. So they literally did not build the harness to plug into it, and yet the hardware's there. Wild stuff. All right. Okay, we can skip on through there. Okay, let's talk about Power Mode Master. Is that what your handout says? Doesn't say Bus Master, does it? Otto and Ralph. One of these days, Alice. Ralph is for my age. Otto's for you younger guys, okay? Who? Ralph who? Jackie Gleason. All right. This is from The Simpsons. Does yours say Power Mode Master or Bus Master? Okay, good. A Bus Master is something for a UART data bus. In UART, one module is the master of ceremonies. It was usually the BCM. Occasionally it was the IPC, but typically the BCM. And so every module had to talk to the bus master. So to this table here, in order for any of you to talk, you had to talk to me, and I said, okay, all right, now it's your turn, okay. And Leo, time for you to talk, all right. And to see if you're there, I would pull you. Paul, you there? And you would answer back. So there was very much an authority thing going on with UART buses, one module being the bus master. Now with Class 2, the BCM is just another node on the bus. He sits around the table, and he's no more in charge of communication than anybody else. And here's how they keep from having more than one module try to talk at the same time. This is just like a conversation. If we all at this table tried to all talk at the same time, we wouldn't be able to hear anybody. It'd be like the Tower of Babel. It'd be just a bunch of yakking, okay? So if it's an old-fashioned meeting and I'm the master of ceremonies, all right, I'm the CEO of your auto repair franchise here. I would say, Ron, okay, let's hear what's going on at your shop. That's UART, and I'm the bus master. That way we don't have everybody trying to talk at once. Now with Class 2, something called arbitration takes place. Remember those ones and zeros we talked about? When the data bus goes low, we all keep talking. The data bus goes high, we can all continue to talk. But when one of us drops off and the other one continues to talk, the one that dropped off stays dropped off. That's called arbitration. So it's what's called dominant versus recessive bits. The dominant's typically on those kind of buses, the high part of the bus, the high part of the square wave, the recessive, the low part. When you had modules all saying the same thing, 1, 0, 1, 0, they kept talking together until one of them got his message, which went down, and the other one stayed high. That module continued to talk. Now, how they design that to where it makes sense is like, well, who gets to stay high and have this last say so, or I should say, take the floor? It's the module with the priority message. So that particular module and its priority of message would be the one that continues high and the other ones drop off. So it'd be kind of like if we're all gentlemen, we don't need a CEO to say, all right, now everybody shut up, it's Ron's turn to talk. Instead of being like that, we're more like Chip and Dale, the little cartoon squirrels, after you, no, after you. It's more of a gentleman's thing, oh, I'll be quiet, you've got something to say, and the other modules drop off. So that's called arbitration, and that prevents data collision. That is a different topic from this. That's called busmaster versus arbitration. Busmaster with UART, arbitration with class 2. This is something different. This is called power mode master. The reason I went into that, they're sometimes confused. The power mode master versus busmaster. The power mode master is typically also the BCM, occasionally the cluster, like late 90s, early 2000s U-Vans, Silhouettes, and what's the other ones? Transports, Montanas. Those, the cluster did the job, but usually it's a BCM. Power master. Think of power. Not every module has an ignition wire going to it. And even modules with ignition wires going to them, if they have a data bus, power and ground, and the ignition wire is not working or something, they can wake up from a class 2 message. But definitely modules that don't have an ignition circuit, switched, accessory, ignition 1 and so forth. Those modules have to be told to wake up via class 2 message from the power mode master. It just basically says, okay, radio, time for you to wake up. Radio, time for you to go sleep. Well, that made it square again. Thank you. All right. So we have off asleep, off awake. We have run. We have wrap. Different power mode accessory. Run, crank. Those are different modes you can have the ignition switch in, and those are different modes the modules can be in their state of awareness, awakeness. They can be awake or they can be asleep. Practical tip. The Tech 2 has a method for checking the accuracy of the power mode master. And that's what it looks like. Tech 2 owners, you've all been in there, right? You've all been in there? That's great stuff. Class 2 check. You can see all the modules on the vehicle that are on the bus, who's got a code, who don't. You can clear the code. You can't tell what the code is. Unlike with Chrysler Star Scanner, you can't tell what the code is in this mode, this menu. But you can at least see if it's got a code. So if you went into Class 2 DTC check, after you'd worked on a car and thought, well, maybe I set 4 or 5 false codes just monkeying around with it. I want to clear those out real fast. Don't necessarily want to reset the clock on the radio and other things. Maybe lose adapts, with this, that, or the other. I don't want to use my battery saver because I'm always running my 9-volt battery down and forgetting it's in there and opening the car door and making the dome light run through my 9-volt battery. So I just want to do something short of the battery cable disconnect to clear my codes, but I don't want to go into every one of the 20-some modules that are on that bus and see who's got codes and clear them out. I got to go to the chassis, now look at all that stuff. Now I got to go to body, because you got powertrain, body, and chassis in your Tech 2. Got to go to body. Okay, do I even have a DVD? I don't know. Oh, no communication. Must not have one. Oh, I do have a rear door control lock module. You hit that. Oh, no codes. This is a quick way. You select this. Boom. There's all the modules that are on the bus talking. Says who's got a code. You click, you highlight that one. You clear the codes. You're done. Class 2 message monitor, we'll talk about that a little bit. Class 2 power mode, what it looks like is you basically, enter that, and you see if the state on the screen of your scanner matches your ignition switch position. So if you got the ignition in run, engine run, you know, it should not say off awake. It should say run. So if you look and you see you have something like that, you have a power mode mismatch. And that can explain a lot of weird things going on. You're in wrap when you turn the key off, but you don't open the door. So we see what the BCM's thinking. This is going to tie in with a case study here. The case of the 2001 Malibu. Who's seen this case here that I've done? This is the case of the haunted radio. Who's heard the haunted radio? Mike, you've heard the haunted radio story. This was a Myron Stein who owns Aircept. You guys ever use any Aircept stuff? Little screens that go in the back of compressors, that stuff you spray the evaporators with to clean them up so they don't stink anymore, and those wonderful modules you can install that runs the blower motor so that the stinky evaporator smell doesn't come back, the afterblow module. Myron Stein came to me at a MAX convention. He says, I got a real challenging problem for you. On just certain GM platforms, the last couple of years, we've noticed that there's customers are complaining, or shops that are buying our products are complaining that after the afterblow module, this is what it looks like. There we go, page 1-27. After that guy's installed, the radio comes on by itself. Now, the idea of how that works is you cut a wire going to your blower motor. You wire this thing in series with it. And then this thing's also got a couple power wires, a couple ground wires you hook up. So when the key's off, after you've left the car, 10 minutes later, after it's dripped enough, the HVAC, the evaporator coils, after they've dripped enough, the blower runs to dry it out so you don't have the stink come back again. Well, after that was installed, the radio would just come on by itself. The customer would get the vehicle home from the shop, and they'd be all happy. Well, I hope this works, because that thing that's really is smelling. That doesn't smell today and everything. They get it home. They walk in the house, hang the keys on the hook, you know, get comfortable, get their feet up on the chair, turn the TV on, and boom, the radio's on in the car. They think somebody's out in the garage stealing their car. They run out there, you know. Nobody out there. The car's haunted. And they correlate it sometimes. You know, the Cincha problem. Since you fixed my smelly air conditioner, the radio now is coming on by itself. So we started investigating why Myron's module was causing that. It's got B+ ground and 3 relay wires. And how does the radio work? Well, the radio doesn't have ignition. Remember, it's class 2 what? Power moded. Class 2 power moded. So the radio gets a class 2 message, says wake up by the BCM. We started looking at the BCM. We discovered that the BCM is the power mode master. By the way, that's how you tell who the power mode master is. Look at the schematic of who you suspect it is, and look and see if it's got all the ignition wires. You know, ignition 0, ignition 1, crank, accessory. If it's got all those wires going to it, it's got to be the power mode master. Why else would you have all those different ignition source signals going to it? And it's also going to be on the bus. So the BCM is definitely the power mode master. We looked at the schematic of the HVAC system, and there's Myron's Aircept module, afterblow module. There's the red power wire. You hook up to a fuse source of power. There's a couple of grounds, actually, you hook up. And then this yellow and white wire, you actually cut. I have a little black box there where the cut was made. You cut the power feed to the blower motor. This normally closed relay, closed in this position unless it's in high blow mode, and then we just get a big current through this big fuse here that runs the blower motor. But anything less than high, we get power from here. So from your HVAC blower fuse, that makes sense, 20 amps, any one of these speeds, drop through any one of these resistors in your resistor card, and then goes up here through this normally closed relay. And if the key's on and we're in normal mode, we're not in afterblow mode. We're just running the blower, driving down the road. And the key's on, this is connected internally, like it's a big loop in there. In fact, when you turn the key off, until the afterblow module does its thing, It's connected, as if the module was never there. It's just like a little jumper, okay? It's when the module turns on, after it waits a certain amount of time, temperature is sensed in here, it thinks it's, it could be a stinky day. We could have some microbial mold, whatever, grow in there. So we're going to run the blower motor. So when this thing decides to work, you know what it does? This jumper in here, it opens it. Then it takes power from here and runs it right down to the white wire and blows the blower motor for a few seconds and shuts it off. It does this 2 or 3 times and it's done. When that would happen, that's when the radio would come on. So we tried to figure out what in the world is about the blower motor and the relay and the HVAC resistor and the head and all that. What's causing that to make the radio come on? So we started looking at the fuses. And there's our HVAC fuse, the 20 amp blower fuse. And it's on the same bus bar in the fuse panel as the fuse that goes to a cruise control fuse and gives you one of the ignition 3 or ignition 1 to the BCM. So when the BCM sees this fuse go high, guess what? It thinks the key's on. We probed that with a meter. I mean, we had a ball. We were out there for the Mac convention, but a guy named Bob Stewart at AC Delco and I, we went to the auto parts store, bought a cheap meter and some sockets and stuff, and took the rental car apart. We just happened to be a Malibu. And we discovered that there was a voltage here that looked like this. When the blower module did its thing and ran that blower motor, then shut it off, we seen the spike on that fuse line. Because the question now is, what do you get when you take power away from a spinning motor? It makes a generator. Now, the generator of the motor, if you will, let's go back, as this came to a rest, so we were disconnected here, right? So we were isolated from the car, am I correct? So if this jumper is pulled, we can't get anything from the blower motor back feeding into the car and into that fuse across the bus bar on the fuse panel to the other fuse, which makes Fred, the BCM, thinks the key's on, which makes sense. It would make the radio come on. If the radio was on, when you turn the key off, it's going to be back on, class 2 power mode, when the thinks the key's back on. So the BCM was seeing this spike of voltage when this thing turned off. What's it do when it turns off to this jumper? Closes that jumper again. Now, how would you fix a problem like that? Everybody says the same thing, a diode. That's what Bob and I thought. So we go down, everybody else is pulling the one-arm bandits. We're going to Radio Shack, man. We're having fun. This is the funnest Vegas trip I've ever had. And I'm sick. I'm all ate up, I know. But this is how I have fun. So we went and we tried to find a diode, specking it out, going, well, that thing's going to take about 30 amps and, blah, blah, blah. The Radio Shack ain't got no 30 amp diodes. You know how big a diode that'd be? That'd be a big old honking diode. And Myron ain't going to put one of those in every box of this thing. I mean, you might as well just put a $10 bill wrapped around that thing. So somebody else had another idea. When I got back to Kokomo, capacitor. Not a capacitor, a simple $2 or $3 cheap relay. That when you turn the key on, it closes this circuit. You turn the key off, it opens that circuit. So there's no feedback. Now the next question somebody asked me once was, well, how's come it doesn't happen you turn the key off normally? Because think about it, when you turn the key off, you've got power going this way, right? You turn the key off, isn't power going to be backfed? It certainly is. We did that. We turned the key on and off. We didn't exercise by the way, that dryer module has a button on it. You can press and test it. You don't have to wait 10 minutes. You just push the button and it runs into test. But we did this. We had the same voltage spike. You turn the key on and back off. We had a voltage spike. But guess what? This voltage spike registered by Fred over here, backfed over there. When the key's off, initially for the first few seconds, Fred says, forget that. That's just a voltage spike from the blower motor. It's programmed. But it doesn't expect the voltage spike to be there after 10 minutes. So that's why it thought the key was on and turned the radio on. The relay fixed the problem. All right. GM LAN, it's a... General Motors answer to Robert Bosch's CAN, Controller Area Network. Been around 20 years. It is the world standard now. And there's one of the first cars GM stuck it on, the Malibu. There we go. You got to have this with your Tech 2. Some scan tools have the software built in. I believe OTC, Genesis, has it built into it. Some of the Snap-ons, you have to have the candy bar, they call it. I think the Modus does not need it, but the brick does, right? All right, okay. Auto Ingenuity does not. All those laptop-based systems, they just write software to do the job. There's some of the early applications. Clear across the Ford line. Mazda was jumping into it. GM started out in 04 and so forth. By 08, everything's supposed to be CAN. Before we go into CAN, though, I've got this stuck in there. Keyword 2000. It's like UART, only it's 12 volts. Keyword 80 and 84. There's a couple 80-somethings. They were like the old UART. Actually, they were like UART 8192. And the keyword 2000, I misspoke. Keyword 2000 is a lot like class 2. Move that down, I'm a little bit hot on the mic. Okay. So it's about 10.4 kilobaud, but it's a 12-volt signal. And it is not variable pulse width, so we don't widen it out to make a 1 turn to a 0 if you're into that kind of techie stuff. There's keyword 2000. Typically, it's just for diagnostics, so you won't be seeing it having communication between other modules a lot, like a whole bus-wide thing. It's just a side module, sidebar, if you will. And we're going between a what is that, an engine control module? Nope, a headlamp module, and going through a little pass-through jumper in the fuse panel, and then up to the DLC of pin 7. So pin 7 is a keyword 2000 in this vehicle. All right, we talked about what GM LAN is. Class 2 only had one baud rate, although they could turbo, if you will, turbo the speed of the PCM from 10.4 kilobaud up to 40 kilobaud for programming. Same thing goes on with CAN. They have a low-speed bus. It's called GM LAN low speed. It's also called a single wire bus. So you may see LS GM LAN. You also could see SW GM LAN or SW CAN, and the SW is single wire. Most of the higher speed CAN buses, or all the higher speed CAN buses, are 2 wires. But there's a single wire bus for CAN we're going to get into next. And it basically is a lot like class 2, only 3 times faster. It's 33 kilobaud, and it's turbo mode when it's been programmed, flashed. It's about 80 kilobaud. Now I want to talk about this class 2 message monitor for those of you guys who are maybe going to buy a Tech 2. I talked to a guy at break time. He's talking about actually he's going to go get a Tech 2. I want to show you something cool that you can do with one. Not that buying Bosch stuff helps me, but having a Tech 2 will help you. Okay, what I'm going to do is I'm going to pull up my TIS, and I'm going to put what's on my Tech 2 up on the screen. Hopefully.
That assistant doesn't pop up.
Tech 2 view. Now, the scanner is responding. It went blank when I did that. And now I got to go turn on the communications. And voila. Now I can control this with either the Tech 2 or the computer. So let's go ahead and hit enter. I can do it like this. Boom. And we want to go to diagnostics, don't we? Let's build a vehicle. Let's build one, say something you'd see a lot in your shop, a 2003. Now I've actually got to move down like this. Giving my mouse too much credit here. It's still a Tech 2 without a mouse. There we go. Now let's pick a truck. We want to work on a Silverado? It doesn't matter, because at this point, when you chose it was a 2003 truck, now you're going to go to powertrain, body, or chassis, and you're going to select what kind of vehicle it is. It's a C truck or a T truck or S or whatever. We're going to go down to diagnostic circuit check. If you've never seen this before, this is cool stuff. Because diagnostic circuit check used to be, back in our day, okay? It used to be when you turn the key on and you look to see if a check engine light was on steady. And then you took your little shorting bar and you stuck it between A and B. A was ground and B was diagnostic enable. That told Fred to start flashing code 12. And that was the first step you did. We never did it because we put a scanner on there and did it, without doing that. So that was kind of like boring. But with the Tech 2 in Class 2, it's not boring at all. You get to this thing we saw earlier, DTC check. We can look at all the different codes in any module. We can also look and see who's communicating and who's not, who says active and inactive. We'll get to that. And we can also look at the power mode, all right? Now this DTC check and this Class 2 message monitor, all the stuff you're seeing right here with GM LAN, it's gone. In fact, let's go ahead and see if we can find it. Let's hit exit. Let's go get a GM LAN car now. Exit again. Let's go get a newer car. Let's go get an 05 Chevy Malibu. That would be in your bay probably any day now, if it's not already. Passenger car, Chevy. What is the fourth digit of the VIN for a Malibu? Isn't it a Z? It's called the Epsilon chassis. Same thing as the Pontiac G6. Epsilon chassis is the Z body style. Yeah. All right, Z car. HVAC or PCM or whatever, and actually go work on that part. Or you could do what now has replaced Class 2 message monitor, power mode, and all that kind of stuff. It's called vehicle control systems. They've laid that out, the Tech 2, like the service manual. Wow. If you got SI 2000, you notice they start to look at the ohms. So you don't want to see 120 or 300. You don't want to see 80 or 90 either. Might be a no start like Mike's talking. All right, page 1-44 shows you the resistor. Some of the schematics actually show you that that module has a resistor inside of it. There's the BCM, and the other resistor is over here in the PCM at the other end of the line. By the way, the PCM is going to the end of the line here, which ends up going to the BCM, which ends up going where? To 6 and 14, meaning it's high-speed LAN. What's this guy doing for? What's he doing? That's for the people who don't have candy modules. They can still take their brick and they can get, that was cool. They can take their brick and they can still get Class 2 and look at serial data for your engine control. So they have some redundancy. But what does that make that PCM now? Remember that term? If you're on more than one bus, you are a gateway. So the BCM is a bit of a gateway too. So if you had two buses having problems, it's Class 2 high-speed, or Class 2 and high-speed GM LAN. Suspect the PCM. It's on both buses. All right. Okay, case number 4, page 1-44A. Chevy Malibu, no start. 04, Tech couldn't get modules to communicate with his Tech 2. This is a true story. This is right off of the GM Tech Assist database, which I still have grandfather access to. And he calls Tech Assist. It wasn't Mike, okay, at his GM store. It was a guy who doesn't take training because he didn't know he had to have a candy module hooked to his Tech 2. This is a brand new car. It hasn't even got 100 miles on it. And it came in on a hook. It won't start. And the technician spends a week piddling around, finally figures out he needs a candy module, can't get his candy module to work right. Finally, a field engineer is dispatched. He gets the candy module to work, and he finds the low-speed bus shorted, the single-wire GM LAN low-speed bus shorted. Now, what's not working on this car? What was the customer complaint again? A no start. Is the PCM on the high-speed bus, right? This is the low-speed bus that's shorted. What's going on there? The solution, another shorted radio. You guys will be replacing radios Monday, you know. Here's how it worked. Page 1-44C. Actually, it's a handy chart to tell you on some older stuff. Well, older for me is 04 and 5. Older for you is probably, what, 99 or something. Or 89, if you're independent. Because you guys see them 5 years and 10 years down the road. Chevy Malibu, that's the vehicle line. What bus it's on, what module's on which bus, high speed, low speed. Is it on class 2? Is it on keyword 2000 and so forth? What's GW stand for? Gateway. So if the module's on more than one bus. And what's PMM? Power Mode Master. Who is the module that knows the ignition switch position that could say, wake up? In the case of the Malibu, the gateway is the IBCM. What in the heck is an IBCM? I got a camera on one here. Do I? Yeah, okay. There, that's an IBCM. Now, it kind of looks to me like a fuse panel. Does it look like a fuse panel? Well, you got that Delphi name on there, so you know it's good, all right?
No, we'll be fixing it.
We're not in Chapter 11 with anything to do with quality. It's all that labor cost thing. Just get rid of enough people, we'd make money. All right, they'll get rid of me if they hear me talking about it. Okay, there's Delphi label, made in Mexico. See, you know. All right, in this fuse panel, which is called a BEC, right, Bus Electrical Center, they have put the BCM in there. Not a new thing. Doesn't Ford do it, and they call it a smart junction box? They had a GEM module. Who's Ford? Who's Ford? Who's good Ford people in here? Nobody? Okay, God bless you. All right, no. Actually, they're a good customer now. They're a good customer. Ford put the GEM module into their fuse panel. It calls it a smart junction box. Any Chrysler people, isn't there a IPM? Not instrument panel module, isn't it? Was it Yeah, under the hood. Didn't they incorporate their BCM into the fuse panel finally? I believe they did. So manufacturers are doing this quite a bit now. That guy, just think, you see IBCM, Integrated Bus Electrical Center. It's a fuse panel and BCM combined. I can recall the GMT 360s, the Trailblazers, Bovadas, Envoys. Remember you pull up the back seat cushion? What's underneath there? The TBC, truck body controller, and the fuse box. How are they connected together? A ribbon cable. And this is a really neat little thing. You slide out and you can disconnect the ribbon cable so you can separate one box from the other. The fuse panel / relay center from the truck body controller. By the way, truck body controller is TBC is another word for a BCM. There's a lot of names for BCMs these days. In fact, this is pretty cool. Let me think about this. Okay, I know where to go. I'll just tell you what he saw. He went into the body menu, okay? On the Tech 2, it's got all the lift gate modules and radios and HVAC and airbags. Anything that's not powertrain or chassis related is in the body menu. And he goes down the line, he's looking for his BCM, and he sees this line that says BCM S. Yeah, think of it. SBM, BCM, SBM, TBC, and DIM. I think there's one more in there, IBEC. And he went to that line and he goes, I've got this, but I don't have these. They weren't communicating. What are the other things? Other names for the same thing. This guy was a fairly intelligent guy, and that threw him off. They like to over-proliferate names at General Motors of BCMs. Here's my box, my collection of BCMs. There we go.
One of them was going down.
There's an SBM, standard body module. There's a DIM, dash integration module. I don't know what this is. It's made by Motorola.
The radio.
It's a BCM of some kind.
The radio.
All right. Memory seat module. It's a peripheral. It's part of the BCM family. Passenger door module, driver door module. It's just too much proliferation. Truck body computer, TBC, RIM and IPM. They're all members of this stuff in here. Okay. Now I've lost my mouse here. So anyways, that's something you're going to run into. So if you see a line and you see on the line of list of acronyms, you see BCM on there, it's the BCM. We just call it a BCM generically. Now on this particular case, we had a no start in a Malibu. The technician couldn't figure out he had to have a candy module. He finally figured it out. He got it on there. The service field engineer, he's there helping, and they discover that the GM Land low-speed bus is shorted. Now it's shorted to ground, so what's it going to take out? All these things you see here on page 1-44C. The IBCM, which is your body control module, by a different name. It's got a fuse panel built into it for the I. A radio, vehicle theft deterrent. Oh, wait a minute. Vehicle theft deterrent. We need that to start, don't we? How can it start if the vehicle theft deterrent can't get its message over to the PCM? And how does it get the message over there? How does VTD get its message over here to PCM that says, we got the right key? The gateway. So the gateway's down. The IBCM's down. If the gateway's down, we're not going to get any information from this bus to that bus. If this bus is down, the gateway's down, nobody's talking. So you can have one bus required to start the car, but something else on that bus, or something on that bus needs to talk to some other bus to get information like vehicle theft. So that's what kept this car from starting. There's the schematics. We'll skip through that. There's an acronym list. All right. Functional diagnostics. If you've seen this, this is not in the powertrain world, guys, because the powertrain world, the EPA owns that for OBD2. But in the other world, the body and chassis, they say we're getting too many codes. We already got too many acronyms, okay, and too many different modules that do the same thing. Now we're saying we got too many codes, so we'll have a code and we'll put two numbers after it, actually. This has just been implemented along with GM Land. It's got nothing to do with GM Land. It was implemented at the same time they did that. When they changed the scan tool layout from Class 2 message monitor, that kind of thing, to vehicle integrated systems or computer integrating systems, and they changed the service manual around, they also changed the codes. So the codes will have two more digits, so like a P0, or I'm sorry, like a U1016. What was the U1016? PCM's not communicating on the bus. After the U1016, you'll have two more digits that say something more specific. Not communicating on the bus because, and we got something else on there. Examples. Let me find a good example. Here we go. Right there, 1-53, a B326501. Or it could be a B326506. The 01 is the BCM detects a short to battery in the trunk relay control. 326506, the BCM detects a short to ground, and so forth. So now we got a little bit more specifics there. Helpful in diagnosing intermittence and everything. Okay. Let's get on to chapter 2. There's some pictures of places and things. We talked about repair. We talked about candy modules. This is the thing to remember about BCMs. There's basically three kinds. There's the traditional BCM, whereas one module does it all. There's the zone BCM, which splits up the work the system does into 3 different modules that are in zones. 100, 200, and 300 zone, basically, of the car, electrical system. The DIM is the 100 zone. It's the one in the front. Dash integration module. That is on page, here we go, 2-7, located behind the instrument panel under the right side insulator. IPM, they're showing a little box right here, mounted also under the dash. Instrument panel module, that's the second, I call it the BCM Trinity. That's the second of the 3 modules. The third is the rear integration module in the back of the car, in the shelf package somewhere, or behind the shelf package, the seat cushion back. Now, those 3 modules, DIM, IPM, and RIM, they comprise what used to be just one BCM, a centralized BCM. They just split the work up. For example, if there is a button, we'll say a trunk release switch in the glove box, and you're going to push that button to operate that trunk, what's the closest module to that button? Might be the dash integration module. So a low current, discrete, it's either 12 or it's not, signal goes between that switch and that DIM. The DIM then gets on the data bus, calls up the RIM, who's where? In the back, closest to the trunk release module, or the trunk release solenoid, and it says, hey RIM, need the trunk popped. And the RIM's the watchdog and says, oh well, I got to make sure I haven't heard the PCM saying that we've got an issue with the speed, vehicle speed. I'm not going to pop the trunk if the vehicle's moving, obviously, and things like that. And if everything's kosher, the RIM pops the trunk. The IPM is not always a module that looks like that. It's not always some little black plastic box. What else can the IPM look like? A what? That's IPC, instrument panel cluster, but you're on the right track. It's one of 3 parts Delphi makes that you can see. Radio, cluster, climate control. On Cadillac, the IPM is the climate control. The instrument panel module is not a BCM under the dash. It is in the dash, in the IP, looking at you with knobs and a display on it. So the same device that's a smart control head that's got sun load sensors and ambient sensors and discharge duct temperature sensors and all that kind of stuff going to it, and flat pack motor outputs, that same little box, that smart air control head, is also a data bus player in the BCM world. And think about this, if you hit the rear defogger, where's that button at? Usually in the air control head, which is also, in the case of a Cadillac, an IPM, instrument panel module / air control head. It's going to get on the data bus, and who's it going to tell to do something? The RIM. So the RIM gets a message from the IPM, which is actually, in the case of Cadillac, a control head for the HVAC, and it carries out the signal. That's one kind. So we had 3 kinds. We had a central BCM like you're used to, something like this, or remember the old days, the old metal boxes. That's the BCM, okay? And then we had the split system, zone systems, and then we have IBEX. You guys know what IBEX are, right? We talked about that. The bus electrical central fuse panel relay thing with a BCM built into it. Okay, we know all the things it does. It's a serial data gateway, does watchdogs for things like, do I have the wrong airbag module in the car? If I've got the wrong airbag module in the car, the BCM is in charge of being the watchdog to turn on or to tell the cluster via class 2 or CAN, tell the cluster, pop on the airbag light. I don't like the part number. It doesn't look good. It's a part number for some other vehicle. The bag might go off. It just would go off after you do this. Or maybe it goes off early and then you hit this limp, deflated bag. Either way, you're hurt. And you didn't get the airbag helping you. So when you set up a BCM, one of the first things you have to do is you have to teach it the part number of the air. It's one of the modes we can see on the Tech 2 when you go in and replace BCMs. It could be the HVAC AC request intermediary. If you've got an old-fashioned HVAC head that's not on a data bus, and you've got a wire that when you push the snowflake button, it goes to 12 volts. It goes to that BCM. The BCM then gets on the bus and tells the PCM under the hood what's going on. They want the AC to work. It does power moding. We've talked about chimes and alarms. It can do personalization for HVAC seats and mirrors. Or you could have a separate, I call them peripherals. You know, like you have a computer at home. You also have a printer and a scanner and other things. Peripherals. It can do peripherals for memory personalization.
You may have said it before, but I don't know if I heard you. When you check communication between module to module, it's, you know, obviously it could be binary, whatever the case. With this scope, is there a certain voltage scale we should know to stay within to make sure if there is any kind of communication?
That's a difficult thing to do. What his question was, when you're checking for communications between various modules.
Right, as we were just saying, for example, we want to open the trunk.
Okay.
Okay, so the module up front is going to talk to the module in the rear.
Right.
Now, say for example, we just want to see if the module in the front is telling the back module, hey,
Right.
you know, what can we do to just kind of like eliminate a step?
Nothing short of using the factory tool, scan tool.
Okay, so say the factory scan tool, well, I have one. I'm just trying to think as I'm talking to you.
Okay.
You know.
I think I know where you're going. You would go to the module, you look in the schematic, and you say pop the trunk, as an example. Look at the schematic and okay, where does the trunk switch wire go? Let's say it goes to the IPM, all right? Then you would take your scanner, go to the IPM, go to inputs, hit the button for the trunk. Does the scan tool say yes or active or whatever when you push that button? It does? Great. I still don't hear a clicking noise in the back though. Now you go to the rim. You back out, you go to the rim, and if it's got a split zoned BCM system, and you see if the rim's getting a message for trunk open request. Let's say it is. Then go to outputs of the rim and see if the rim is saying, I'm giving it the outputs. And if the rim's saying, I'm giving it an output, and you take your test light and you back probe that terminal that's supposedly going to the output to that solenoid, ain't nothing happening, it's time to go buy a rim. But if the rim's not seeing a request for trunk, but the DIM who got the message from a hardwired discrete input is seeing you got a request, then you have to assume the rim's not getting it because the DIM's not sending it or it can't receive that signal. Now there's where you really can't figure out if it's the rim or the DIM.
Right, without the factory scan tool, I mean, just give up.
No, this is with the factory scan tool.
No, I'm saying with the factory scan
Oh, just
tool,
forget
understand the
it. Just forget it. You can probe with the meters and the scopes and stuff all day
So
long.
there isn't anything on a scope that we could technically see, like on a fluke scope or any type of particular scope. There's no signal, a glitch, a little twitch, anything that we could see?
This group I work for has a bunch of guys over in Philadelphia, in Morrisville. You probably saw the guys on the video. What's his name? Jim Moore. Excellent. Jim Moore is an excellent instructor. That group has got this tool that they're selling to the aftermarket called a DS800, and it does current-based diagnostics. Instead of back probing for volts and ohms, that's traditional, you pop a fuse out, or you put a probe or cut a wire, pull a pin out, and you do current-based diagnostics. When you push a button, the current should change to a certain amount. They are saying that some serial data diagnostics can be done that way. Now, that's something I've not been able to actually experience myself and see how accurate that is, because the serial data bus message is very busy all the time. And it's very, very small amount of current, minute amount of current. So I don't know if, actually Jim didn't tell me they were doing that, somebody else told me they were doing that. So I don't know if that's absolutely true or not, but that's pretty Rube Goldberg in my opinion, but I may be wrong. Something like this is the only way you're going to see exactly the message is being sent. The Tech 2 sees the tip of the iceberg. The Snap-on of the OTC doesn't even see the tip of the iceberg very well. It sees the tip of the iceberg from binoculars, okay? The Tech 2 is on the tip of the iceberg. something like this engineering tool. This is by Dearborn Group out of Dearborn, Michigan. It's called a VSI. There's boxes made in Kokomo, Indiana, a little job shop that does work for Delphi and Kokomo called CSI. You remember that because that's that TV show about crimes, right? CSI makes a box called a Saint box. That's an acronym. You know what their box was? It was a predecessor to the Saint box. Another acronym, Demon box. All right? I thought that was kind of funny. Demons and Saint, they got a Saint too. And what you have to have is a laptop computer. So you're thinking, no big deal, I'll buy that. I bought an Auto Ingenuity for my laptop, I'll buy one of these. And the software, which is hard to get because it varies from system to system, car to car, and be really intelligent and have inside information. For example, Class 2, some of the Saint box messages are spelled out in English. Some are like what Doc's going to talk about this afternoon in hexadecimal with Mode 6. Only there's no Mode 6 website. There is no hex website for GM LAN and Class 2 messages for the average person to go to. You've got to know the target and source and the structure of the message. You need to be an electrical engineer that does that kind of work on those cars. Those guys can actually look at that, scrutinize it, and you'll actually see a whole page of small font on your computer screen, a whole page in a second worth of data transmissions. That's how much stuff is going out. You don't see that in the Tech 2. You see a little page that changes, periodically. Boom, 1 second, the screen is full of messages. There's messages that say, I sent you the message, and you send a message back and it says, I received it. All that's going on back and forth. We really would need that to determine if the DIM didn't send it or the RIM didn't receive it. So it still comes back to a little bit of guesswork sometimes. Okay, so you got the three kinds of BCMs: centralized, zoned, and built into the fuse panel. All right. Mall modules were early BCMs for battery rundown protection only. Audible alarms and chimes. MyCams, same thing. You could short two wires on the DLC. Back then it was called an ALDL on some of those cars. The J and N cars were the Sunfires and the Grand Dams and so forth. You could short the wires. The dome light would flash diagnostics. And I think I actually got that procedure in the book for you. Yes?
That one with the battery protection runs on, is that for real?
Oh, definitely. The question is, is this thing for real? Can it really keep the battery from running down? It's limited. The BCM is up to its eyeballs in battery concern. Number one, BCMs, whether they're the old early MyChems or MAL modules or the newer stuff like DIMs, RIMs, and IPMs. The DIM actually is part of it that does battery runtime protection. It's broken down into really three categories. Number one, if you leave a dome light on, you open the door, you forget the door open, you leave a trunk up, certain accessories will be shut off after 20 minutes of inactivity on the ignition. The ignition's not been on, it just pops. You've seen that. Maybe you wanted to leave the dome light on when you vacuumed your car out and it went off. You had to go get your keys, stick it back in, turn it back off, get your dome light for another 20 minutes. Parasitic, that's one type. Parasitic current draw is another type. After 30 days of inactivity, and on some of these modules, if the car had less than 50 miles on the odometer, it was 3 days of inactivity. You would shut off parasitic current draw. Not to everything, but a select bunch of Freds had no keep alive memory. That means that their 5 and their 10 milliamps didn't all add up together, so that at 40 milliamps, if a worst case scenario, when Granny went to Florida during the winter, and she came back to Michigan or New York in the spring, the battery wasn't dead. It shut those things off. Oh, you lost your codes, and the clock said 12 once you turned the key on the radio, but no big deal. So that's parasitic battery rundown protection. You can have problems, and that doesn't work. You can have things stick on, and that doesn't work. But it was designed to keep parasitic battery draw down, and also the inadvertent accessory. That's actually a circuit you can see in the service manual. Inadvertent accessory, it's an output of the BCM. The BCM will turn off things you inadvertently left on. The third thing the BCM is doing these days to try to prevent battery rundown, battery failures. A big enemy of batteries is undercharging and overcharging. Now, Chrysler's been using their computer since the 80s to control voltage regulation. Ford has since, I think, the 90s. GM has had a regulator inside the alternator since 1973. Now, it got smart in the 80s, where when you turned on all the field draw, all the battery draw, like blower on high, headlights, rear defogger, heated seats, all that junk, you turn it all on, the voltage regulator didn't just suddenly, wham, give 100% duty to the brushes and make that poor alternator, start squealing the belt and working too hard, because sometimes that would stall the motor or put the motor into a vibration. So remember when we went to a 2-wire voltage regulator to what? A 4-wire voltage regulator, P, L, F, and S, 4-wire voltage regulator. Remember that in the 80s? It would gradually pulse width modulate, ramp up the duty cycle to the brushes in the alternator so that when you turn the loads on, it did it in a smoother manner. But we never had the computer control it. Then the late 90s comes along. Have you been noticing where the L terminal goes on your Delco alternators? Now, Bosch alternators. We quit making alternators. Do you know where the L terminal goes now? The L terminal was that one wire you needed to make an alternator work. In fact, all these alternators, for years and years, you could take a test light and you could hook the alligator clip to B+, unplug the regulator terminal connector, start the engine up. Obviously, it's not going to charge. The regulator is disconnected. Take that test light and touch the L terminal. Or better yet, put a terminal, a pin, a jumper on there so you don't touch the wrong thing. Touch that test light, which has got power going through the bulb. Touch that terminal on the L terminal. What should the alternator do? It should begin to charge. That's an easy, quick way to do what we used to do, short the D terminal out and full field them, all right? So the L terminal, instead of going to the lamp, that's what L stood for, in the dash, it now goes to the PCM. And then another wire from the regulator, the F terminal, it goes to PCM. Who can tell me what those two wires do now? Does the PCM control the L terminal? Like, does it turn it on and off to get more voltage out of the alternator? No. You turn the key on, the PCM provides a reduced current limited signal to the regulator on the L terminal. If the L terminal is grounded by the regulator, which it will be if the key on and the engine stopped and the alternator's not turning, then the PCM says, okay, good, I'm seeing a ground here. I'll tell the cluster on the data bus to turn on the charge light. You start the engine up, the alternator's regulator takes that ground away, and the PCM sees that. What's the PCM tell the cluster to do? Turn off the cluster's charge light. Then if the alternator quits, gives up the ghost, quits charging, turns that ground on, the PCM sees that ground, what's it do? Tells the cluster, turn the light back on. We're not charging now and we're running. What's it do with the F terminal? The regulator is autonomous. It makes its own decisions. It turns on a certain duty cycle to the brushes to give a certain voltage based upon, number one, the calibrated voltage, which we all know ain't 18, it's not 9, it's what? 14.5. Or is it always 14.5? It could be 13. It could be 14.8. Temperature related charge rate. Temperature of what? I don't see no wire going from the alternator to the battery except the big battery cable. The temperature of the voltage regulator. So the voltage regulator gives a certain duty cycle to the brushes. That duty cycle is what the F terminal is about. The F terminal is read by the PCM and it says, oh, you've got about half duty cycle. Okay, that's about this much load on the engine. Oh, you went to a 90% duty cycle. Oh, that's a bigger load on the engine. The alternator is going to work harder now. I need to know that because I do engine management, all right? Now, enter the computer, true computer-controlled regulation. Those same two wires that for several years now have been L and F, and where do they go? To the PCM. Did the PCM control voltage regulation? No. It was a courtesy to watch the light on the L terminal for the light in the dash and it also watched the F terminal to see the duty cycle. Regulated voltage control, guys, has been around since 2004 on certain models of cars, and you may have noticed some of the trucks have this big module-looking thing on the battery cable. Have you seen that? That's a standalone regulated voltage control system. And on other cars, have you seen looks like somebody forgot their inductive test clamp around the battery cable? You seen those? That's a current sensor. You know who's reading that? The BCM. The BCM is looking at serial data and saying, you know what, I see that the intake air temperature is X, and the coolant temperature is this, and the RPMs and the length of time we've been running. I'm going to make what's called a virtual sensor, battery sensor. You know what a virtual sensor is? It ain't a sensor at all. It's just looking at other values and going, I'll bet you I know what the battery temperature is, because I know what the engine coolant is, I know what the outside ambient air temp is, I know what the intake air is, I know how long we've been running, and I've got a pretty good idea from modeling and software, all these parameters, I know the battery temperature. So the BCM looks at battery temperature and says, oh, it's 70 degrees outside. We'll give it 14.8. Oh, it's 13.5. Oh, it's 30 degrees outside. We'll give it 14.8. Oh, it's 100 degrees outside. We'll give it 13.4 or whatever. So to give it the right amount of voltage to keep the state of charge of the battery above 80%, the BCM is working with the PCM to actually control the L terminal. The L terminal now is being turned on and off by the PCM, working with either a standalone charging module, it's called a battery control module, generator battery control module, GBCM, that thing on the battery cable of the trucks, or it's working with the BCM. The PCM's working with the BCM and making a determination of how much to charge. So we truly now have computer-controlled charging on GM vehicles for the first time in all those years that we've had wires going between the alternator and the PCM. Now we're truly doing something about it. And the BCM is the big cheese. So there's three things the BCM's doing: parasitic current draw, inadvertent accessory draw, and now it's involved in regulated voltage control. That wasn't in the book. Okay, the rest of this stuff is basically just BCM, how it works. You guys, I think, pretty much know what a discrete input is now. A door jamb switch, for example, is a discrete input. Page 3-2. There's some examples in schematics. Door jamb switch, and the output is the light bulb. Another example on 3-5, a door lock switch. And the output would be the driver door lock actuator or passenger door lock actuator based upon software looked at in the BCM. You know, is the RKE commanded and things that would inhibit locks and so forth. So how would you diagnose power door locks? How did you used to diagnose power door locks without a BCM? How did you used to do it? Customer comes in, says, I hit the button, nothing happens, no clunk. What did you used to have to do? Check fuses, and then what? Then the door panel's off, right? When you're back probing stuff behind the door panel. Now what do? If you've got a Genesis or a Snap-on, and it's just a BCM, and it doesn't have any peripherals, it's not one of those chunked ones, 3 zones, DIM, RIM, and IPM. It's just one BCM, and there's no driver door modules and liftgate modules and crud like that. It's just one BCM, and it does the locks. You're in luck. Your Snap-on, your OTC Genesis, it can do the job. You can look at the input on the BCM when you hit the switch. And if it doesn't say active when you hit the switch, what are you going to do? Pull the door panel off, right? Maybe back probe the input from the door panel switch, and if it's getting a voltage change on your voltmeter, pull the door panel off. But what if it says active? Then what are you going to do? Then you look at the outputs of the BCM. And the BCM is saying it's not trying to do the output. Then you look for something that might inhibit. You read up and go, could there be anything else that can inhibit the BCM if I'm carrying that command out? Because it doesn't want to carry the command out. Typically when they're bad, they try to carry the command out. But they just can't do it. So if you don't have anything that inhibits it, then I guess you replace the BCM. If it says it's trying to carry the command out, you check and see if it's really doing it. You go to the back probe, the back of the BCM. You go to the door lock actuator output. You know, you got a positive, negative, depending on which way you're pushing the button. And you just take your meter, your test lights, you probe in there. You take your power probes, if you're getting a green or a red, or both, you know, when you hit the button. And if you are, door panel comes off, right? Time to put an actuator in. If you're not getting that signal, what do? Install a BCM. By the way, dueling power probes are ideal, because not only can you read the BCM trying to do it or not trying to do it, while you're back probing, you can flip the switches and you can do it. Then if you can go chunk as you give power with one power probe and ground with the other, and reverse it, go the other way with the door locks, you've just taken 3 tools, 2 power probes and a Tech 2, and you've done in 30 seconds what you used to have to do pulling door panels and junk off in, what, a half an hour or better. Now, let's just say you diagnose, I'm sorry, you have a question, somebody?
Nope.
You diagnose a bad BCM. You go put it in. What's the steps to replacing them? We need to zip through here. In fact, let me just skip down to configuration versus flashing. That question came up at break time. We've already talked about power modes, which was chapter 4 or 5 or whatever. There we go. Clear up here, chapter 9. Configuration. Configuration, I think we kind of touched on that earlier. I told you I got a Pontiac G6 and I had my Tech 2 on vacation, and I went into BCM, strictly done with the Tech 2. You don't need the Tech Line terminal to download anything. You go into BCM, you select BCM setup or new BCM setup, and you go into configuration, and you'll have questions. You'll have a list of things that you'll have to put asterisks next to or remove asterisks from. Is it a overseas car? You know, does it have rear fog lamps? You guys know what rear fog lamps are? You guys back up real fast in New York where you need fog lamps to see? Turns on the amber turn lights. In some countries, there's a mandatory, like in the Autobahn, you have to have your amber turn lights on in fog. So when they're coming up behind you, they see that amber. You don't see the red lights necessarily, they see the amber first. So it's for people following you. But you could turn that on, you know, daytime savings, that's tomorrow. Daytime running lamps, all that kind of stuff. ABS, you know, it's an option now. You can configure that to either have it or not have it. And you need to know what you've got so you have it configured correctly so you don't get some false U codes of some module saying, hey, you told me there's an ABS out there. I've been waiting all day to hear from an ABS and I haven't heard an ABS message yet. So you want to make sure that everything is on there that's on there and vice versa. If it's not on there, you don't have it configured. And you have to pull the programming fuse on some models like the U and X vans, which is your Montanas and so forth. And you may underline that, guys. If the BCM says Motorola, and it's in a Chevy W, an Impala, or a Monte Carlo, when you configure it, you better have it right, or you better change it really quick, because you've only got just a short period of time, and it's locked out.
There you go.
You've got to have it configured right. If it says Delphi on it, it can be reconfigured a month later, like the Pontiac I talked about. I'm sorry? 3 key cycles, that's what it is in that time. Thank you. 3 key cycles. So you better have your RPO codes deciphered, located and deciphered. Programming, SPS. Basically, if you can flash a PCM, you can flash a BCM. The same process. So some BCMs are flashed. Most are configured.
I had 2004 Sun View. To replace the airbag module. I could not set it up until I programmed the BCM. I kid you not. And the configuration are in it.
So you put an SDM in it.
SDM in it.
And it says you must do the BCM first.
Well, I had to find out on the GM's website that you had to actually program the BCM before you could set the airbag module. You would not get rid of the B1001 code. I could not get rid of it.
Right. B1001 code he's talking about is called configuration error. And a B1000 is an EEPROM problem. Actually, it's a problem internal to Fred. And with functional diagnostics, we mentioned they have a new diagnostic system now where if it's not powertrain, the 4-digit code now adds some numbers at the end of it. They actually have a breakdown on the B1000 codes, which, like the old code 60-something. Remember old code 60s? You had an old code 66, what'd you do? Threw Fred away, right? Now they're B1000 codes, throw Fred away. Now it's B1001 or B1005, and it actually says RAM is bad, or EEPROM is bad, or ROM is bad. And you're going, whatever, Fred's bad. I'm not going to be soldering in a new RAM chip on it. So when you do pop in a new BCM, you need to do the restraints ID, like John was talking about. You need to do the VTD flash, vehicle theft deterrent. So if you put in a locked cylinder, you put in a PCM, now you replace a BCM, you better do either the 30-minute procedure or the 10-minute procedure. Who's done these procedures? 30-minute or 10-minute? You will be doing them, guys. You'll be doing them before you know it. Who's sending that stuff out? Now that I know there's more dealers in here besides just Mike, I won't say, don't do that anymore. But actually, you can do that too. You can do the VTD, vehicle theft deterrent relearn. The 30-minute procedure is not hard. You basically turn the key on, and don't you wait until the security indicator quits flashing, and then you turn it, leave it on for 10 minutes and shut it off, and you repeat that 3 times. If you have a Tech 2 and TechLine software, it's a flash calibration. Request data with the Tech 2 connected to the vehicle, disconnect from the vehicle, go to your TechLine terminal, shake hands between your Tech 2 and the TechLine terminal, select, I want to flash the VTD, select that, download the calibration for the VTD, disconnect from the TechLine terminal, go back to your vehicle, plug into the DLC, go back to programming, boom, it's done. And it's a very small calibration, so it doesn't take long. I will say, however, the 10-minute procedure for VTD was the only thing that fixed a late model Chevy W car for me one time. And I've seen on I-ATN, I'm not the only one. Has anybody ever had a Chevy W or any other GM car and you couldn't use the 30-minute procedure? You tried it over and over, you dotted your I's, you crossed your T's, you read the directions, you spent 90 minutes wasting time, and you never could get the vehicle to start. Anybody had that problem? John, you've had that? Did you do the 10-minute flash and it worked?
It wouldn't work for the garage. They called me out, I did the reprogramming, boom, fixed it.
What car was it?
I don't remember for sure. But I've had it quite a few times in the vehicles. The flash just works better.
Been more than once?
Been more than once. When they've done a 30-minute relearn, it wouldn't work. So I come out there, I use the Tech 2, perform the VTD learn through the TIS program, boom, done.
Well, you guys can get a Tech 2 and a TechLine terminal, or you can continue to pay John.
Also, on those Malibu, that Hall effect switch in there.
I'm sorry?
On the Malibus with the Hall effect switch, with that 30 minutes, you something that customer comes in, my car won't start. But when it comes to the shop, the vehicle starts. We take the Tech 2 and look to see that 5 volts reference. Sometimes it's down to 92. And they go out and come back, then the Hall effect is bad. Because when you turn the key on, you'll see 5 volts. And after it relearn and reset itself.
Yeah, you should see 5 volts. You turn the key on, you should see whatever the voltage drop is.
They come in with hard starting. You know, right away we know it's the Hall effect. Out. Don't keep checking because you do the thing.
So you're sticking Hall effect switches on a lot. You're seeing a lot of bad ones. Are you doing the 10-minute relearn with the Tech 2?
With that 10 minutes relearn, you can do that.
Yep.
And
Yeah.
the vehicle still
Other shops don't realize, they told them to read the key. It'll say PK2 for pass lock 2. Then there's PK3, which is a little different.
Right.
There's no Hall effect. There's actually a mobilizer. There's a chip in there. So if you relearn this, you think you're relearning the cylinder, customer comes back with the other key won't work. It says PK3 on it. You have to relearn the other key.
Exactly. You have to have all the keys present.
It's stamped on the key. It'll say PK2 or PK3. They made a transition. In late, I think it's 2004 and up or different.
07, well, I'm not going to say this anyway because this is about you guys. I'll let it go.
Oh, okay. All right. Okay, never turn the key off in the middle of programming. Always maintain 12.5 volts. Select replace and reprogram. Circle that, guys. I've got several calls, everything from PCMs to radios to the hotline, and the guy replaced the part, but he went to program. He selected program on the tech line terminal instead of replace and reprogram. When you reprogram, you're only getting a little bit of data, just the stuff that's different for that particular car, for that cow. When you replace and reprogram, it's a whole dose because the module is typically data poor. In the case of the PCM world, they call it a no-start calibration, is all that's in there. So if you already have a car, it's been flashed, you just want to flash an update into something, then you would put in reprogram. But if you're replacing a PCM, you do replace and reprogram, or a radio, you replace and reprogram.
So, you know, I always use the replace program on everything. The reason being is sometimes you get software with an asterisk by it, so you go reprogram, it won't reprogram because it says we need a VCI number. Can't get it. So I just go back in and go replace reprogram, doesn't give the asterisk no more.
So even if you're just recalling, you have a TSB for drivability issue, you go ahead and do replace and reprogram.
Because it'll ask for VCI number and I can't get it.
Takes a couple of minutes longer, but it's worth it because you have less problems. That's a good point to remember. Just do replace and reprogram on everything.
So if you're going to flash, you can go replace and reprogram and you'll still be fine.
Won't hurt a thing, even though the car has been running with that PCM for a year and it just needs a calibration update.
But you still got to disconnect the battery, I think, for a few seconds prior to doing that, don't you?
That's controversial, taking the battery cable off and hooking it back up. Some people touch the cables back together in case there's capacitance out there. Most engineers I talk to, they think that's a lot of hullabaloo. But a lot of guys will say, I fix cars doing that. So it makes a change. So guys, that's it for me. Doc and I'll be after lunch. Enjoy your meal. Thank you.